Good morning, everyone. I hopefully won't talk too much about myself, but I'll tell the odd story which will, I guess, give insights about me. The aim of today's discussion, from my perspective anyway, is to share with you how nature has, over the last hundreds of millions of years, but I'm going to concentrate more in the more recent millions of years, has taken this. Anybody know what this is? You seen one of these before?
Pebble. Rock. Gravel? It's gravel.
Yeah, so it's a piece of gravel, right? So it's a piece of rock. Everyone happy with that? So what is this thing? If I had to try and explain it to you, what is it? Say that again?
Looked like a bit of basalt, didn't it?
Yeah, okay, so Tom's obviously was an accountant in his early days, so, you know, about the bloke in the balloon, and he's lost over the US, and he's got in a big storm and he's been blown in the odd spot, and anyway, in the end he winds up landing this balloon in a field, and he meets this person there and says to him, "Mate, where am I? Hell, I've been caught in this huge storm." The bloke said, "You're in the middle of Mr. Smith's potato field." "You must be a baddie accountant, because you've given me very detailed information, but it's worth nothing to me." Right. So, okay, I want a more general description of what it is. Sorry, Tom.
Compacted minerals.
It's compacted minerals. So it's a really compact, and it's minerals, right? How much space is there in here? To you and I, when we look at it now, I can't get my finger in there. And sure, if I stuck this thing, a whole mob of them, really probably better, stuck them in a bucket, and I filled the bucket up with water and soaked it overnight, and took the bucket tomorrow morning, took this thing out, how much water would have got inside these things? Everybody happy that none would have got in there? How well will that thing, this size, hold on to that water? So if I then poured the water out and then poured them out on the stones there, on that bit of tarmac, how long would the water stick to that?
Not long.
Not long at all. Okay. So what we've got here is actually a piece of soil. Do you believe me? It is. It's the root of soil, if we can use that. Okay. It's the beginning of soil. And I'm stealing this part of my first part of my talk. I'm obviously typical of Dick. I get to listen to all sorts of people, and then I dickify what they said. So make it my own. So there's a wonderful fella called Walter Yaney, who many of you know, and particularly Tom knows really well. So we've sort of agreed that this thing can't hold water. We've agreed that it doesn't have space in it. But you know that you're very wrong about the space. It's just that our observation of it and our current understanding of it, us sitting in this room, think that there isn't any space in it. I'm going to move that further this way so I can stand on the right-hand side of my board. Thank you very much, Tim. Perfect. Yep, that'll be room, because I write right-handed for my sins. Right, so I was talking about how much space there is in this rock to fill in the time. I once watched a documentary, like a TV documentary thing, about how much space there is in a rock. Now, I don't know the distances in Victoria or the size of these towns, so I can't really put it in that fashion. But if we went through this rock here with microscopic ability, and we found a solid piece of gear in there, the size of this room, this building, if we found that, it would be around about 10 k's away to the next piece of solid gear, which would be about the size of this room. That's actually how much space there is in that rock. But to you and I, it's a solid chunk of gear, and what's important is that the water can't get into that. Okay? However, there's a combination of people over the last millions and millions and millions of years on Earth have actually destructed this stuff and broke it up and made separate mineral particles out of it. It's a combination of fungi with their acids. It's obviously chemical weathering and physical weathering that's taking place as well. But there's a bunch of people, individuals who are involved in it. The fungi and the other one are bacteria that actually eat rock, that live inside the rock and eat them. So, anybody heard of gangster town called Johannesburg? Yeah. Right, there's a whole 6, 7, 8 million gangsters living in one place. Johannesburg is, at the airport, is 2,000 meters above sea level. So it's pretty sort of normal height for the Southern African plateau. And at 2,000 meters above sea level, they dig for gold. Just down the street from the Joburg airport, they do the same in the Free State at about 2,000 meters, 2,200 meters above sea level. They're digging at 4,000 meters below soil surface, so they're 2,000 meters below ocean level that they're digging in these tunnels under there, and they find bacteria in the rock that they're digging out to open up with cyanide or whatever they use to get the gold out of it. So that's pretty interesting, isn't it? So the process of life is even at 4 k's underground on one of the few places on Earth that's welded to the Earth's core. These things are working, digging it up. In other words, the southern part of Africa doesn't move, can't move. It's welded all the way down to the Earth's core. And those people are working down there in some pretty horrific temperatures. That's the bacteria I'm talking about. I'm not worried about the people. They've got the job themselves. But the bacteria down there doing their job at that kind of temperature is pretty interesting. You know, they reckon it's about this far away from the guy with pointy ears and a sharp tail. Right? That's if it's an American telling the story. So why am I telling you this story? I'm telling you this story because over the history of the Earth, we've had a scenario where these minerals that are really, really tight together at this end have over time been separated out into what we nowadays call soil. Anybody here still refers to it as dirt? You got dirt, good dirt on your place, bad dirt on your place? Anyone got that? You do? Yeah. There's the door. You're not in the right place. Okay. We're not dealing with dirt here. Dirt is the shit your mother sent you to wash off your face and hands before dinner. Okay? The stuff we're dealing with is something called soil, where these mineral particles that were in this original rock have been separated out and are being held apart by Walter Yaney's words. Dick, never use green, I was told yesterday. I hate not using green. Can anybody not see that? You can all see it? Yeah. There's a lady who can't because she's frowning. She's wondering what the stuff I'm pointing at.
It's the head in front of me, not the, not the green.
Did she say the dick in front of her, or did she say the head? Righto. So these little things here are, in Walter Yaney's words, carbon springs that hold these little particles apart. To you and I, this stuff over here is called, better colour, Dick, brown colour. No, because that'll mislead you, or if I use brown. There's another worse colour, orange. Anybody worked out what I'm writing here yet? Humus, cool. So, what is humus? What is humus?
Decayed material.
No, it's not. This is where the whole beautiful, thank you for saying that, because it's like really jumps me straight in to the failure of all the current training that we get in soils. It's not decayed plant material, humus. What is it?
What the roots of any healthy plant
No, you would have said the same. Come on. Pardon?
Dissolved rock.
No. Humus. What is humus?
Carbon and moisture. Well, a lot of carbon in there.
It's got a heap of carbon in it, yeah. Just wait for old mate to drive past. I hope he doesn't derail. This is Victoria, isn't it, in the train line? So go again there, Dean.
It's full of carbon, it's full of minerals in the right balance that the roots of the plants look for. And it's moisture as well. So.
And fungi and bacteria and all that living stuff too.
Say that again. Fungi, bacteria.
Yeah. And all the living stuff.
Humic acid, fulvic acid, all those other goodies.
Yeah, okay, that's now we're taking it from what sort of happens next to it, sort of, bacteria and all the rest of it live around it. The fulvic acids and the humic acids and all that are all involved in the process, but what is humus? It's very high in carbon and it's got a specific, very near specific balance of specific elements in it. Is everyone happy with that? Okay, but it is not a deconstructed plant material. It is a construct. Has everybody got the point that I'm trying to make here? You have plant matter maybe deconstructed, yes, that's decomposition occurring. So I'm going to start that already on another page. You guys are going to get dizzy with me moving between pages, but I can't do it any other way, so put up with it, okay? Carbon.
Just to make life easier.
Yep.
If you want to rip off those pages, we can stick them on the walls. Does that help?
Yeah, I don't want to, thanks Dean. I may do later when I'm finished with them, but I'm going to keep going back and writing on them. So is everybody happy that carbon, there's carbon in the atmosphere? Yeah, how much?
Too much.
880 billion tonnes. Not enough.
Not enough, correct. How much carbon is there in the atmosphere? 980 billion tonnes. The accountant giving me exact figures again. I just want to say that it's about that in percent, 0.04, it's actually 0.03 something, but 0.04, which is your 400 parts per million translated into a thing that you and I understand like percent, like we were taught that when we were little at school, okay? So there actually is a real shortage of this stuff and we really need to think about it. The other day I was listening to this wonderful article from overseas where this chap was just saying, warning, don't try and put all the carbon away because this is the sustaining stuff for life on Earth. Everybody breathes out carbon dioxide and they breathe in oxygen. What is the net output of the Amazon forest every day in oxygen? A 48-hour period, how much oxygen is the net output of the oxygen of the Amazon? 0. Absolutely round, blatant 0. You can look it up, you can read the scientific papers written by people with PhDs this long after their names. Why is that? I met an 11-year-old kid, year 11 kid the other day, sharp one, ducks of his class, who had not been taught this, and is a year 11, had not been taught this yet. Why is it that other than the carbon dioxide caught up and joined up with hydrogens out of the water plus the oxygens out of the atmosphere to make a carbohydrate which sits in the tree, okay, other than that bit that gets stuck, what happens to the carbon dioxide that the plant breathes in?
It's neutralized.
It breathes out oxygen, right? And then what does it do at night?
Close.
No, come on guys, you went to school. You forget all this shit because you listen to TV, people whacking on crap at you all day. They breathe in oxygen and they breathe out carbon dioxide. Why we know that is because most of you come from Pommyland and stuff, don't you, originally? Like Western Europeans came over here, shackled up and put in the hold of a ship. Great-grandparents. But anyway, you come from that part of the world. The Poms, at the time of the Crimea, do you remember Florence Nightingale? What was the famous thing about Florence Nightingale?
Cleanliness.
What is the thing that I know she's most famous about?
It was hygiene. She insisted on hygienic conditions.
All the pictures I saw of the Darling Lady of the Lamp were always a picture of her opening these things. What was her thing? She was letting fresh air into rooms where people were freaking dying of disease being carried around in the air inside that. She is the lady of the lamp, yes, and yes, hygiene, cleaning, but her big thing, all the paintings, of her opening shutters. Why? Because she knew she needed fresh air in there. She needed oxygen. When I was a kid, they were still carrying the flowers out of the hospital rooms at night into the hallways. Because it was originally a Pom colony, so the Poms had been shut all the doors because the night ills and the night chills will kill us all, shut it all, and the sick people in there full of flowers, the people would asphyxiate and die. Okay, so I'm not having a go at the carbon thing here because it's important. It's very important. What I'm doing is just putting it into perspective. Carbon is, in fact, a critically one of our critical limiting factors to production. Why are cattle only this big, except in Texas, okay? Cattle are only this big. Why are you milking a goat this big and not milking a goat that stands as tall as this room?
Oh, that's a halfway up, actually.
Good on you, thank you. Pull him up the dick. No, the reality is, in the time of the dinosaurs, this was 0.16. There was a shitload of carbon in the atmosphere, so plants could breathe in and make feed, like big leaves, like huge grass plant. They didn't have grasses then, but they had big, like banana plant leaf was a small one, and this thing could just chomp and grow and get the old leg over and grow some more little baby ones out of more eggs and grow more big ones, and you could milk maybe a thing like a dinosaur. Okay, we can't nowadays because we now have plant limited production. Okay, so in Port Augusta they produce nearly all the tomatoes that are eaten in South Australia. Guess what they do in the tunnels that they grow the stuff in? They pump carbon dioxide into there to 4 times atmospheric carbon levels. That's how they produce the stuff. Okay, so I'm not here trying to make a myth of the whole carbon story. I'm just trying to point out that actually we need to understand what carbon's doing, and we need to understand that it's a cycle. It goes into things and comes out of things, and there's processes involved with this, okay? And I'm going to emphasize the importance of carbon today. I'm not here to pull the pea out of carbon. I'm here to emphasize the importance of it, but why it's important. Okay, so any questions at this stage about carbon and the atmosphere? And yeah, go.
Yeah, I've got a question.
Yep.
Can carbon reduce more? Can you make more carbon or less, or is it you stuck with that 0.04%?
No, we're not stuck with that. It goes up and down all the time if you look at the historical record, which is why there's a bit of an alarm going on about it at the moment, because it, yes, has been increasing over the last while. And so carbon is increasing in the atmosphere. That's a given fact. No one can argue about it.
No, but there's a limited amount.
Yes, but
carbon on Earth doesn't change. It just changes form, that's all.
On Earth total, yeah, but we can end up with more available carbon. Okay, there's ways that that's going to happen, and there's ways that that's happening every day. Remember I talked about those little bacteria a minute ago? Okay, this particular rock doesn't have much in the way of carbon in it, but I should have brought one of those white ones. Do you see those little white ones lying outside the door there? They're full of carbon. So the bugs that are eating that are actually going to do all the burp and fart and root and things which bugs do, and let out more carbon into the atmosphere, which actually, into the cycle, okay, into the carbon cycle, which then means actually we've got heaps of other carbon still cycling and coming out to add to our current carbon cycle.
There is a point though with all of this, that it's the cycling of the carbon, so the plants are the ones doing that heavy lifting.
That's right, and that's where we're going to.
Then we go somewhere else.
That's correct, 100%. Yeah. So the point I was wanting to make at this particular juncture here was following up this thing about what humus was and how it's not really decomposition. Okay, so if you've got carbon, this is now carbon that's come out of the atmosphere, it's in plants and animals. Now how does that cycle? One of the methods is something called decomposition. Okay. By the way, if I don't spell something right up here, you spell it right in your notes, okay? I don't really mind that I can't spell right, I've got used to it. I'm the chairman of the... You ever heard of the DNA? I'm the chairman of it. The National Dyslexia Association. Anyway. Right. Decomposition is the thing that we were talking about a minute ago, but humus is not decomposed plant material at all. It's a constructed, nearest to living organism that you can get. In other words, it's constructed very closely to the similar makeup as a living organism. All it doesn't do is breathe and breed and dung and urinate and all that sort of stuff. It doesn't do it. So what it is actually is a hexagonal shaped, carbon built construct, okay, which is, in other words, hexagonal. You know what I mean by that? 6 sides, so it should have been drawn about the same shape as a what's that thing called? The famous thing, the bee wax, you know, with the hexagons in it. But the difference between it and that is that this is helical.
What, sorry?
Helical. So it's built, actually Walter's 100% right when he calls these things carbon springs. It's a typical Walter joke because he's telling you something with a funny little nickname when he's actually telling you exactly what the thing is. He's wonderful at that. So do you follow my logic of what I'm drawing there? I'm trying to draw a spring from up above. Yeah, so it's a helical shape, so the 6 of them make one circuit, but it continues going underneath each other. So correct. So if that's one of them, it curves below and continues down in the shape of the good old coil spring sort of situation. Spiral. Yeah. Okay, so it spirals inside itself. It's six carbons make up one of the circuits, and if you think about what this gives the soil, and I'm going to talk about how it's made in a little while and the difference between it and the deconstructed plant matter in the soil, but what I'm sort of harping on this straight from the beginning because it's critical to the whole story that we're dealing with. What can hold more water, a clay platelet or a sand particle? Clay platelet being this shape, I've obviously microscoped the thing up huge now, so that's the size of it, that's the shape of it, okay, versus a sand particle which would look like this. What holds more water? The clay, because it's got a much bigger surface area. Cool, so that's a platelet. I've drawn it like this. It's actually probably should have been done like my hand. It's this sort of shape, so heaps of space on it, okay, and has it got a charge on it, the clay particle? What charge is it?
Positive or negative?
It's a minus, yeah, it's a minus charge. If I got that the right way around, don't write that down. I could have got it cocked up now the wrong way around. But that, as a dust particle, if that clay particle got into the atmosphere and was now a dust particle, would push water away from it. It wouldn't allow water to connect to it. Okay, but in the soil, it allows other elements to attach to it, which then also allows this water to get to it, and you can have an ionized soil scenario, right? So which has a positives and negatives are available so that other elements can stick to it and water can stick to it. Each one of these acts as a clay platelet. So like a clay platelet. So one pair of carbons, one carbon with its next 2 little angles joining it to the next one, is about the same as a clay platelet. So one little circuit of humus would have 6 times the ability to hold and exchange elements, and which we call nutrients, right? Plus hold and exchange water. Does that sound good? And what's beautiful is it has both charges, pluses and minuses. It can both do cation and anion exchange. In other words, plus and minus elements can be exchanged. It's not just a flat cation exchange, which most of us measure in our soils these days and get sold NPK to deal with, because it's all about these plus ions. Actually, nowadays, if you listen to the whiz kids in soils, Nicole Masters, Christine Jones, Elaine Ingham, long list of wonderful people doing some wonderful stuff. They actually talk about pH and EH, and they talk about plus and minus elements, and they talk about the ability of the soil to trade all of those. Okay? So if you want to know more about that, get on to those people, because I can't even remember half the words, let alone understand their Latin descriptions. Okay. I mustn't forget this wonderful coffee that you got.
Positive, negative, or don't.
That's right. Yeah, I'm pretty sure that's the right way around. Cations positive, anions negatives.
The significance,
anterior, posterior, yeah.
The significance of that is that a couple of the major elements in nature, like nitrogen and sulphur and a few others, have a negative or no charge at all, and the humus, they can't be held in the normal scientists that talk about the cation exchange, but the humus can.
Yeah.
And that's one of the major things humus does, is hold nitrogen.
And it's already made up of 6 to 10% nitrogen in it. So it's made up of nitrogen, but that's not available. Humus is long-term held, it's not available, but that's absolutely, the nitrogen trade on that thing is immense. The trade of all those other elements which we are told are so bad for our soils, okay, like for example aluminium toxicity, because you've got a highly acid soil. Aluminium is now toxic in your soil. Well, guess what? That just means that aluminium's taking the place of other elements on the plates of carbon and on the sands, etc., of clay and sand. And hydrogen is the other one. pH is actually the measurement of hydrogen sitting on those things. These two dudes push everybody else to the back of the queue and out into the woods. When it comes to something like this, like humus, that's physical impossibility for aluminium or hydrogen to annex those people and remove everybody else from the available thing. So you've heard about availability of elements. You do a soil test, which this is what's available. It's water soluble or whatever. This is the total. Well, those may in many cases actually exclude what's in the humus or hanging onto the humus anyway. But you would pick up a very different soil test in the same bit of country if your humus content went up by even a 0.01%. You'd pick up a massive change in the elemental makeup of a soil test. Okay? This thing, like you and I, we made up of carbon. We happen to have the water sort of built into us as well, which this thing doesn't. It attaches to the water, right? But this thing here is about as close to the construct of a living organism as you can get. It just doesn't breathe, doesn't, as I said early on, breed. What are living organisms defines a living organism? It breeds and breathes, isn't it? Yep.
If you can increase your carbon by 1%, I can't remember what the holding capacity for the soils are.
Yeah. It's immense. I can't remember the numbers offhand either, and I'm not going to try and quote them here or draw that up, because you can get a massive lift in water holding capacity from labile carbon. It doesn't have to be humus. Okay?
From what carbon, sorry?
Labile carbon. So soils can have humus. A lot of them don't anymore, but they can have labile carbon. People pump up labile carbon in their soils hugely. You go under a forest, it'll be full of labile carbon. There'll be no humus nearly under those. In the rainforest, up in inland of Cairns, up there, like Atherton tablelands, there'd be very close to no humus in those soils.
Labile means it rises and falls.
It's
so we get
available.
To go cumulatively, it's not permanent.
Yeah, so it's available. Yeah. Reason. So let's just play a colour game. What colour is labile carbon in the soil? General. Black. That would be, a lot of them, those are the charcoals. There's another kind of carbon in the soil too called charcoal, really pitch black. But you do get very close to black labile carbon. You get brown. You get that topsoil differentiated colour in the topsoil from lower down. That is all labile carbon you can see. What colour is humus? Nope.
Brown.
Not really even. But nowadays I'm told it's a very, very light caramel brown. Okay, very light caramel colour. In fact, Christine Jones, and the lady whose book's written on that table, I don't know why Dr. Jones would tell you that, it's not true. Humus, according to Christine, is the colour of beer. Yeah, amber colour. So she's pretty close to that, at the chocolatey sort of caramelly, which Nicole says it is. But it's not dark brown. It's not black colour, humus. Okay, I've got a person I work with who produces milk for Mangali dairies, which is one of the biggest biodynamic dairies in Australia on the Atherton tablelands. He's the one bloke that I've found in Australia who's doing the closest that I've been able to find to the grazing naturally method of grazing, and he produces feed that grows like this in no time at all in that country. So sorry, about up to your knee sort of height. We've had holes dug on his place, which is, I would stand in the soil pit up to my hip here, and they've measured carbon sort of every 10 centimetres, carbon levels through that. The lowest one in his grazing soils is 7%. The highest one was 12% carbon in the soil available.
Soil organic carbon percentage.
Organic carbon, soil carbon percentage, yeah. The colour of the soil, it's the colour of this gentleman's shirt from top to bottom. There is no brown layer on top of that soil. Zero brown layer. The biodynamic guy who's pretty famous up there, and he's actually a great bloke. I always pull the piss out of him, but so I'm allowed to do that just without his name. That same day we had that soil put open, he's having a go at this dairyman. Watch that door doesn't clap you on the back of the head there. Now maybe just move forward a 6 inches or so, because it'll blow open again and I won't be held responsible for the ding on the back of the nut that you get. Anyway, so our mate's in a bit of a tiz about this because there's no brown differentiatable topsoil on his soil, but he's got those kind of percent results, and this bloke didn't know at that stage. Christine was the one who said to him, mate, you can't see humus with your naked eye just looking at the soil. You will not see it. It will not necessarily give a colour. When you spill that beautiful beer on the counter, what colour are the droplets? You can't see the amber colour in it anymore. It's clear. You can see through the stuff, you know. Once it's out of mass, you can't really see the colour. So in fact, we can have a soil with 7s to 12s, this much down, that's all red because of the oxidised iron in that soil. That's what's giving it the red colour, and it doesn't have to have the brown chocolate layer on top, and it can be full of humus. I'm talking about a soil that if you dug a column of it out like this and you dunked that in a 44-gallon drum and lifted it up by the roots of by the hair on the plant's leaves up at the top, pulled it out, that soil would not disperse and spread everywhere. It would come out and it would still have that intrinsic structure in it. It's beautiful. It's like, this is a big example. It's not that big, but it's just crumbs. The whole thing is crumbs and they stuck together. You cannot push your fingers into that soil. Okay, you will not be able to push your your fingers into a humic rich grazing ecosystem soil. You will not be able to do it. If you do, you're not in a healthy grazing ecosystem driven soil. I'll explain what you're in a minute. Yeah, but within a little while you should know what it is you're in. But you're not in a grazing based ecosystems healthy soil, if you can push your fingers into it. Okay, you get your finger in a little bit, but by then your nail's trying to leave your finger, right? Because these people in here, let's call them people for now, are holding that soil and giving it structure and strength. Okay? Right.
Can you just comment on
Yep.
the qualities of more permanent humus as opposed to labile humus?
No, not labile humus. The modern day, I know that the Oxford Dictionary still has it cocked up. Humus is organic matter in soil, but the Aussie one, what do we call our Macquarie? The Macquarie has it now separated, that they're two different things. This is soil carbon, made up of charcoals, made up of labile carbon, which means it's available basically still for organisms to eat and use and work on, and humus, which is long-term stored built carbon. Yeah.
My question is just commenting on the long-term, the permanence of the
permanence. Cool, Dean. Yeah. So what Dean's saying is so important. Humus in a soil is a really long-term thing. It's a building block which sits in there and holds soil and holds those little mineral particles apart, like we're drawing it on there, for a very long term. They reckon the lifespan is 100 plus years, right? It has cation and anion exchange capabilities. It has water holding, retention and exchange capabilities. And it builds the structure in the soil, or it doesn't build it because it doesn't live, obviously.
The best metaphor,
but it's built by somebody.
I've heard when you're looking at humus, look at jelly. Like when jelly forms, you can drop it in water, drop it in anything, it all hangs together. It's sort of like it's amorphous in that sense.
That's cool.
Has the dairy farmer been doing this?
Say again?
Has this dairy farmer been
How long?
working on it?
Well, he's been doing very close to the grazing naturally thing for about 15 years. Yeah. And can't remember how long he's been producing for those guys, but he changed his grazing practice about 15 years ago. And he's doing pretty close to what I'll teach you to do
What did he start
today.
off at? What level, do you know?
Of humus? No, I can't remember. Yeah, I'm afraid. Yeah.
Where does biochar slot into this?
Can we leave that on the question list for later on? Okay, you write that down and just make sure you ask it later on. But it's going to sort of derail me if I'm on here at the moment. Except to say that biochar is labile carbon. Okay, yeah, that's what it is. It's available carbon. Has anybody ever put compost on their soils? It's labile carbon. Okay, it's decomposed organic matter. It's carbon. It's carbon, but it's in labile form. It's got carbon in it, so it's not only just carbon. Anybody put a mulch on their soil? That's carbon, but it hasn't been turned into labile carbon yet. Okay, where's it going to end? It's going to end as labile carbon, as I'll draw for you in a minute. Okay, the chances of a mulch being put on your soil ending up as humus is about as close as the chance for me to get pregnant. Okay, in other words, it's less than 1%.
What about compost?
Compost is labile carbon. Some of it might be able to end up as humus, but again, it would be far less than 5% of it could end up as humus because it's labile carbon. Okay, the construction process of humus is different to the deconstruction process to make compost. That's not saying compost is bad, because this is what I'm reminding us in the beginning. Remember, labile carbon is good. We need the stuff in here. We don't need it all going to humus. We need a whole lot of it to be able to get in here, to be utilised, to grow again, to cycle, to make it work, which is what that article was about.
Is there a difference between composting systems? For example, people have compost that, we have is based on already out of got these open lounging sheds, and we have a deep litter builds up. So once a year or twice a year, we take that out. It's fairly decomposed. It goes into a great big heap, and it goes like a rocket, and it turns. And so we then
gets hot, you mean?
Pile as long as this room.
Yeah. And when you say it goes like a rocket, gets hot and active, so that's decomposition happening.
Yeah.
Yep. Yep. So what you end up with after that decomposition is broken down, separated carbon in a labile form. Yeah. I know there's a mob, and they're great people. I'm not having a go at them, who sell humus compost. It's not humus. It's compost that's made to look like what we imagine as humus, because it's got a similar look to it to an earthworm poo, right? An earthworm cast, which is why we should do that. So there may be bits of humus in it by the end of that, but only depending on the organisms that are there. In the decomposition process, humus is not made. Okay? The carbon construct, in other words, plant material, dead animals, or whatever it is going to be, is deconstructed. It's separated out into elements, and it's separated out into carbon pieces. That's a decomposition pathway. Humus follows after anything of that. It's a construction. Okay. And we'll look at how it happens in a minute. And I'll end up with more pathways for carbon here on this picture. You just have to bear along with me. Now, I'm spending a lot of time on this, little bit of it here, because I think it's so important for us to identify that these are different kinds of carbon in the soil. A, B, that there's differences in how they got there, and C, they've got different roles in the soil, and they're all just as important as each other, okay? One isn't more important than another. And what we have to remember is, and we're going to spend some time on this, I'm going to take you back to the evolutionary process today here, and show you how these processes have occurred and how this construction has ended up with what we are, and how different ways of doing it will end up in a different construct. Okay? Right. So we're cool that this process here of separating my little rock, which by now I've strangled half to death, and opening it out into separated mineral particles held apart by carbon springs, called humus in this case, is a process of making the soil more deeper and more mature. This is the famous process of evolution, which has been called soil genesis. I can't remember how many ends are in Genesis, that's why I pulled up. I'd always get stuck. There's probably 2 ends, eh?
No, it's right.
Only 1. Cool, I'll give it a go then. Pedogenesis, so the making of soil, the evolution of soil is what's happened. Now what I believe, and you see by my little logo that I've got for my business and what I call my grazing method, is that this occurred over millions of years, and it occurred with Mother Nature's own interventions and activities. There were no caterpillars involved. There was no spreading of nitrogen, phosphorus and potassium by a spreader truck. There weren't people particularly in there making compost to spread. Nobody went out there and particularly made any of that stuff happen. It happened by its own accord. How did nature do it is what I want to know, because if I know how nature did it, and at the moment we've got a fair swag of new knowledge come out in the last 10 years or so as to how nature did it, now I can go home and repeat that process. Now I can drive that process from being, you know, one of the outcomes of this process. I can now maybe take, accountability for my little patch of country that I'm calling mine, and I can be part of the process of making this happen. So what I'm heaving on about that is that you really can achieve this without the polypasture species. You can achieve it without disc planters. You can achieve it without all that stuff. Obviously, that stuff is great because it speeds up the process and can get you there. So if you've got a very valuable piece of country and it's not giving you a return, it's more important for us to keep you on that piece of ground who've got this positive thought than to lose you. So go and spend some money and get the process going quicker so that you can make more profit out of it and stay on that piece of land and make it work in the long run. Because if you don't, you'll have to sell it, because by then the bank's knocking down your door and somebody else will take it on, and all they're going to do is potentially what they're going to do. They could be, say again? Subdivide. Yeah, they could subdivide and put houses on it, exactly. Or get on it and give it another good pizzling for another 200 years and not make it happy for anybody, right? So I'm not having a go at any stage against any of those other methods. In fact, I encourage them, but it's about profitability and availability and whether you can do it or whether you can't do it, okay?
So,
yep.
Dick, I think it's a really critical point, because all of us here we've got land in various states of conditions, and a lot of it, I think it's fair to say, is degraded and it's wanting to be healed and sorted out and improved. And we're also moving into a phase with our program where people can participate in doing some small trials and demos on their own land.
Yep.
So I'm hopeful that as coming out of today, we'll all collectively learn about what we can do on a patch of dirt.
Yep.
Particularly those bare patches that are really
Patch of
suffering.
soil.
Although we become soil.
Yeah, good on you. Well defended, Dick. Well done. There, the patches of dirt turning into soil. That's great. Okay, cool. So that's where we're going to go to today. And yes, I will refer to those other methods and how you can use them a little bit, and the import of how they can be used, that sort of thing. But remembering that the key thing I'm talking about here is grazing naturally. How did nature do this to make this happen? Okay. So in this process, obviously, there's been a whole heap of evolution take place. Everyone happy with that at this moment? And then I better just pull up and say, righto, back to questions again on this job here, on the difference between humus and labile carbon. Everybody all right with that? Okay, cool. So we're going to come back to that picture potentially later on. It may be ready to put out with the blue tack job, but this picture is not. I'm going to add a whole lot of stuff onto that picture as I go along. So what I'm going to do now is I'm going to have a little session. Maybe we've got a little bit of time. It's now 10:15. So yeah, no, fine. We'll do this little section, okay? I'm going to talk a little bit about evolution. So I know I'm a bit of a kid when it comes to drawing things, but I'm drawing something in the plant kingdom here, and I'm a kiddie drawer. What have I just drawn? Tree. Okay, cool. So this is our plant kingdom that we're looking at above this line, and their roots below. ground, and we're particularly looking at this end at a tree. What does a tree do? Photosynthesizes, and what does it do with the outcome of photosynthesis?
Lays down wood.
Lays down wood, cool. Okay, so there is some, in the leaves you will find that there is some cellulose, and I'm only telling you that because I got into trouble from someone the other day because I didn't mention the cellulose. But as a general thing, trees are mostly dealing in the world of wood, which is lignin. Okay, how digestible is lignin? When did you last sit down and eat a dining room table? Hey? You didn't do it for some time, right? So let's talk about that dear old tree out there. When that tree is growing, which part of the tree trunk is the living part?
In the middle.
No.
The outside.
Outside. Most of the Australian trees are hollow in the middle. Everybody's eaten the middle out, or they haven't eaten it, shit word dick. They've decomposed the middle of it out by using acids, which they spit out and eat it. So a termite doesn't ingest the stuff, it squirts out the acid to eat it, gets it in, okay? The fungi does the same thing. It's external to its body. It's not a digestion, it's a decomposition, okay? And the outside of the tree is the living part. In fact, in that beautiful big specimen standing over there, there's not a single cell in that tree that's in use today except a structure to hold the tree up that's more than 7 years old. There's no cell that's actively alive that's more than 7 years old in that tree. Anything that's 7 years old is dead wood, holding the tree up. Okay, it's quite important this because the number 7 is a very important number in nature, and you'll see the same number 7 repeated again later on when we get into the animal kingdom, when we discuss it if we get that far. But anyway, so the roots underneath the tree that go down into the ground, what are they doing?
Seeking out minerals and support.
Some minerals, yeah, main job.
Water.
And what's the other job? How much, you know those windmills, are the ones that make electricity? Well, they tell us make electricity, the big chaps. Yeah? What holds it up? What holds up the windmill? Yeah, which has got how many tons of concrete in it? 300 tons of concrete under one of those buckets to hold it up. That's a shitload of concrete. So if you've got a tree that big, what keeps it from just falling over when you get a bit of a north wind come through? This thing here, right? So it looks for a bit of mineral, searches for water, and its main job is to hold that tree up.
It seems though that with the eucalypts that it's the root system coming out this way from the tree. Because when a tree falls over,
it's often not much going down.
Not going
yeah,
down.
That's right. A lot of them don't. Yeah.
Like this,
yeah, but that's
quite close to the surface.
so we could draw some of those guys like this, or guys. You know, when I use the term guys, blokes, and that, please, I'm talking about all
living creatures.
Thank you, darling. That's very sweet of you. Okay, because I have, you know, I can maybe upset people. I keep talking about guys, but guys are people. It's all people, okay? So these people that go underneath are those ones. They're still the big ones, though. They're holding it up and they may be searching for mineral and whatever. Because it's very important what I'm about to point out here is that a tree's fine roots are all up at the soil surface. All its fine roots. Do you understand what I mean by fine? So like, I've got none to show you, but that stuff, that fine stuff, okay, is what's at soil surface. So these are the ones that actually forage for your current turnover of nutrient, or the fine leaves. Is everyone happy with that statement, more or less? Okay, so what happens?
That's sort of why rainforests survive, isn't it?
Yep.
Because it's all that surface nutrients.
That's right, surface nutrient, 100%. So we don't actually have any rainforests in Australia. We have near rainforest things that we call rainforest, but that's because as Aussies we're desperate, like, you know, to win everything, so we even use sandpaper at cricket matches and shit. So we would call a forest which is a near rainforest, but they're not. They have dry seasons, our rainforests. They actually hold up for a while. So during that period, these leaves that fall down to the soil surface actually do build up in our rainforest forests, and then during the wet season those things get decomposed by our decomposers. Okay? And if you go to the rainforests up Atherton now, or up there, the soil actually is bare mud at soil surface. They've eaten all the old plant material that fell down. It's just bare mud on top. But a proper rainforest would still have a whole lot of gear, like half covering that soil. And if it was a temperate forest, in other words, a forest that would be further away from the tropics, you'd get a very seasonal big dump of organic matter on it if it's deciduous, in other words, drops its leaves all at the same time, and you'd have those leaves breaking down, and because they'd break down slower there, you would have still mulch or litter layer at soil surface longer periods of time. So like where some of you might even have been related to Robin Hood, you know, because the criminal background sort of thing, the Robin Hood. So old Robin, and then they lived in the Sherwood Forest, didn't they? And that had a huge thick litter layer of leaf lying on the soil surface. Okay, and this is what the tree does. So who decomposes that and puts it into the soil, or available to these trees? Fungi. Beautiful. I'm going to do both fungi and bacteria, so don't feel left out if I haven't done the bacteria bit yet. But the decomposers in this show are fungi. And the main mob of them that I'm interested in are people called saprotrophs. Their names have been changed from saprophytes to saprotrophs. Well, I wouldn't understand why, but I've been told. And these fungi that we're talking about here in the saprotroph mob are visible to the naked eye. Who's seen them? What do they look like?
Mushrooms.
Yeah, mushrooms is a different breed of them. They're not saprotrophs, but say again? White. And they look like spider's webby sort of mycelium.
Something on your muscle, that white.
That stuff around the outside of your muscle, the sheath or whatever. Fascia, that's a jobby. So they look not unlike a spider's web of thick white fungi stuff. Everywhere you go under a tree that's allowed to be a tree. They're not allowed to be trees here, because somebody comes and brings a mower and mows it, and there's probably a bit of Roundup going in there as well by the smell of it when I went through early on. But anyway, so mowing and Roundup here is not allowing that tree to be a tree. There was one down there that is being allowed to be a tree. So what happens under these trees? They build up a mass of thick organic matter and mulch at soil surface, and the visible saprotrophs, and that's not awfully visible what I've written there. So do I need to rewrite over the top of them to make it work? But I want to conserve blue for the next mob of people. Can you guys see that, or do I need to? There you go. Righto. Visible fungi, and it's a saprotroph, so I'm not going to write over the whole damn thing, take too long. Okay. Anybody ever stuck their nose in that? Do you have? What does it smell like? Say again?
Beautiful.
Do you reckon?
Very pleasant.
So why did Robin Hood spend his life living and sleeping in a freaking tree and not sleeping on that ground?
Actually, there's probably no oxygen down there.
It's full of this top layer here is actually quite high in oxygen. But why wouldn't he sleep on the ground?
The sheriff would have got it.
Pardon? No, because Ronnie Biggs, you heard of Ronnie Biggs? You would have heard of him, the famous Ronnie Biggs?
No, if he'd slept on the ground.
Okay, but I'm telling you about Ronnie Biggs now to explain why. How did Ronnie Biggs escape the police catching him after he did the greatest train robbery?
Dunno.
He just lay down on the forest floor and did this, and the leaves lay there, and the policeman stepped on him as he was searching for him through there. Could not see him. Nyaniso, read the book, The Greatest Train Robbers. 100 story from the man's own mouth. I met the guy who flew him out of Australia, by the way. So, good people. Anyway, all looking after their cousins. So, he wouldn't have slept on that ground because of the smell of the mould. This smells, ladies and gentlemen, it smells of mould. Have you ever heard of something called a deep mould? Anybody here heard the term? You better go back to the archives and have a read. Because this is so important, what I'm talking about. And because we're being taught such bullshit these days by so many people, that I'm here as one of the little saviors running around trying to stop us being taught too much bullshit. Mold. You heard this word? Yeah, so you go and visit Granny down in East Gippsland and you haven't seen her for 6 months, and you're the same visitor in his name in the visitor's book who was there 6 months ago. It's been a long, wet, cold, miserable winter. I guess you guys get those here, so you know what I'm talking about. And you go and you get shown into the guest room and you open the door and you just... I'm going to die of this mold smell, and yeah, Gran leaves the room, you just... diving, open the windows, let the polar bears in to try and get this thing to freshen up because it's going to kill you. You're still intrinsically terrified of molds. You're intrinsically scared of molds because of who you are. What is that smell at the back of the jock's cupboard in the laundry? Keen on that one? Penicillin growing across the bread. Come on, guys, you know what I'm talking about, don't you? Mold, right? So I'm not just a weirdo. The soils of Australia were described by Hume, Leichhardt, and Mitchell. All three of those people described the soils of Australia as deep molds. It's the only continent in the world where grasslands soils were described as deep molds. And you're going to work out just now why that's the case. You're going to have to tell me. So visible saprotrophs, moldy as ever, breaking down organic matter at soil surface, making it available for surface searching roots to look for those minerals to grow again. Producing lignin. So if I had to look at the animal kingdom, how many animals live off these things? And not a lot of them. There's insects, yes. They live off the cellulose part of it. Okay? Even the koala lives off the cellulose part of it. Okay? Deals badly with that too, but has a go at it. The termites are actually external eaters. They squirt out an acid to break down the plant material, to decompose it, break it down outside their bodies before they ingest it. The wood grub worm does the same thing. Squirt, squirt, soften it up, acid, break it down. It's an acid world. These people here decompose, they use acid to do it. Where's the black one? That's colour, not used enough. Acids, and it's external to the body. It's not an ingestion process, it's a decomposition process. So that's carbon in this woodland. Where does the nitrogen come from that the tree needs to make green in its leaves and the photosynthesis process? Comes from the air. Perfect. So our nitrogen's hanging around up here, same as our carbon was, hanging around up there for this thing to construct plant material with. How does this tree get the nitrogen? Every breath it takes is full of nitrogen, but it can't use that nitrogen, right? Every breath that you take in, what's the percentage of the atmosphere that's nitrogen? 78%. So we breathe in huge amounts of nitrogen. Can I use that nitrogen? I've got to go and eat a steak to get that nitrogen, right? Because the protein part of it. Protein is a carbohydrate with a nitrogen stuck on the end in simple terms. Okay? So where does this tree get its nitrogen from? You guys know. You can be brave. I'm not going to say no again. I'll try not.
Thunderstorms. Rain.
Rain, that's right. Every raindrop's pumped full of nitrogen, every thing, yeah. But that's also just getting into the soil here.
The rhizobia in the roots.
The rhizobia in the roots. Beautiful. So we're talking about, in the bacterial community here, a rhizobium is a bacteria, right? Where does it live? You said it so nicely, Dean?
You want me to say it again?
Yep.
The rhizobia in the roots.
And he said, in the roots. Did you hear the key word he said was in the roots? Okay? So these rhizobium live in the roots. They make little bumps in the roots. They are endophytes, meaning they live half in or totally in the root of the plant. These fungi people we were drawing up here in these trees are largely ectophytes. Now, no, that's not 100% true, but it's pretty freaking close, okay? Saprotrophs that are visible working in woodlands are ectophytes. They live outside of the plant. They do not have an end of their tendril. With these new rules, I'm not going to be able to do my little job there that well today, but what I would normally do is I'd grab Dean's arm now, and I'd link arms with him, okay? So we're holding on to each other, okay? We like the government of Australia. Hey, Dean, we're going to build a new airport outside Warwick. You're going to buy the land, and then we'll buy it off you for 10 times, million times more than you bought it for. Inside a trading deal. Do you understand what I mean? This is how we do it inside. So endophytes here get paid by the tree in what they want, which is the sugars, okay? They get paid by the sugars, but inside the root system, because the conditions outside of that root system are not good enough for them to live. They have to live in the root. So what the plant does is it cheats. It does two things. One, it pumps acid into the soil to loosen the soil up enough to get oxygen there, oxygen there, to get air there, to get nitrogen. And then these people get paid in sugar, and they pay back nitrogen. But it's an endophytic, it's an insider trading job. Everyone happy? Okay, these people are ectophytes. They scavenge and break up detritus on the surface. They make that available to the plant. That's how the plant pays them. It's an ectophyte thing. It's loose. That leaf could go anywhere. The leaf could get picked up on the wind and land up in a glacier in New Zealand. The tree can't control that, but the conditions are so cool there that it doesn't matter. We just toss these leaves out and let anybody pick them up eventually, in the belief that somehow or other we'll get enough carbon to do the job. Is everyone happy with that? Okay, but this is an endophyte job.
The rhizodia are endophytes.
Endophytes. So, the carbon cycle here, of course it's not 100%, but is largely a process of decomposition. Is everyone happy with that statement? Okay, I think I've proved it enough there today that it's decomposition. Okay, did decomposition, was it able to create humus? No. If any, remember, it was about as much chance as me getting pregnant of it creating humus. Very, very small chance. Most of that carbon is going to end up in a labile form, highly available for other things to use and live. Good thing or bad thing? A damn good thing. We need this to happen. Is everybody happy with that? Okay, I'm not saying labile carbon, bad nose, right? Okay, so far.
That this whole process is decomposition. Is that what you said?
Of the carbon part of it is decomposition. Right. Yeah, the tree grabbing the carbon out of the atmosphere and utilizing any bits of carbon it gets from here is a composition thing, making mostly lignin, but there is some cellulose involved. Okay, in the process. That's a construction. This is the destruction of again, so the carbon can cycle. The nitrogen itself has to be available for photosynthesis, and this is the method that it gets it. It pays for it on an insider trader. It doesn't use any free throws of carbon, sugars, this is, to feed to people in the bacterial kingdom to get the nitrogen. It does it on an insider trading. Okay? But what we're ending up with is labile carbon. Any carbon that's lying around here is labile carbon.
Right, and that's decomposition.
Yeah. Yeah. Thank you. Cool. Righto. We happy? Over millennia, we obviously went from algae and slimes and all these people, lichen on the land. Eventually we had these people. They were the trees, the dicots. When they first come up, they've got two leaves. They're the original plants. They were the beginning of evolution. They were the beginning of succession. Okay? With them, you've got a smaller version of them. But otherwise operates in the same way. Does anybody know what that thing is? Say again?
Seedling.
No, just the ones that when it's adult, it's only this big. Shrub. Okay, so that's just a smaller version of a tree and operates in the same way. Is everyone happy? Right, what happened next is we had an evolutionary wobble take place, and we had the development of some new people. These people are something called forbs. Anybody heard of forbs? Where's my rubber today? Oh, what? My eraser. Forbs. What's the difference between a forb and a tree?
It's a grass.
No, grasses aren't forbs. No. Oh, shit, I said I wasn't going to say no. Grasses are not forbs. Sorry. Yeah, you said something, didn't you? Oh,
I just said it was a weed. We like to call them weeds too.
A lot of people call them weeds, yes. A lot of them have got taproots, but this is, you see, the first ones of them, as Paul's pointing out, the first of them were taproots, because all these people up to now had been taproots. But these were the cross-dressers. These were the change over time when evolutionary process said, hang on, we don't have to operate in the lignin world only. We can now begin to create more cellulose.
So they have bigger leaves.
They hardly have any lignin. They have mostly cellulose. So none of you, early on, you told me, none of you had actually sat down for dinner to eat the wood dining room table, okay? But you do eat some things that are like relatively similar. Who's eaten a piece of celery here? Is that a tree? It's not a tree, right? It's got some stuff on the inside of it called pith. Most Aussies think that's what you do at 2 o'clock in the morning when you walk out of the pub, is you go for a pith, but it's that styrofoam looking stuff that they make eskies out of, is the pith that looks like the stuff they make eskies out of. The inside of a plant's full of pith, or it's hollow. Who's ever eaten a lettuce? It is a forb. Okay, this is the stuff that people were able to eat more of. Your animals can eat heaps of this stuff and digest it because it's got much more cellulose. So it's now beginning to get into the realm of more digestibility. And the intricate difference between a forb and a tree is this. When we said that tree, the living part of the tree was on the outside, just underneath the bark. Okay? Where's the living part of a forb? It's on the inside. The outside bit is the hard bit to hold it up. It's the opposite way of a tree. It was an evolutionary whoopsie that somehow occurred for forbs to happen. And in this process, a whole lot more things happened. We didn't just have tap-rooted forbs. Okay? Like a lettuce, is it a taproot? It's now started to have more tendrils of things going out. Lucerne. Who's ever seen a lucerne plant? A lucerne plant is forbs, right? They're either hollow on the inside or they have pith on the inside. And those depends on which ones they are and how healthy the soil is, it seems. But anyway, it is a forb. It's not a tree. Okay, it's a forb. And yet it's got root systems which have multiple roots all heading down, beginning to create fibrous root systems. Who's heard of a clover? The clover is a fibrous-rooted forb. Who's seen really good things like calthrop, marshmallow, nettle? All those people are forbs, and it's for the first time that we have a changeover in root systems from these tap roots to carrots, for example, and radishes, and turnips, and bulbs, and fibrous roots. What was interesting here was that this was the first time that we began to shift away from all our fine roots up at soil surface to have fine roots now foraging low down in the soil. And for the first time, plants began a process, a whole new method of getting carbon into the soil called by Christine Jones the liquid carbon pathway. In other words, root exudates. You heard of that term? Or riser sheets, is what the net result is. So these plants actually push sugars into the soil around them. I wanted to go back to this jobby because we've now got two more things we can add to this list of carbon cycling methods. One of them in the scientific books fits under decomposition. Okay, so in the science I'd have to draw this from here, okay, but I'm not going to because I'm allowed to. I couldn't give a rat's bum. This is the world according to Dick now today, so I'm going to go around decomposition and I'm going to call this digestion. I'm drawing a massive distinction between something that's been ingested and comes out of the rear end of that animal that's eaten it in an ionized form. In other words, the ions are separated and available. The anions and cations can link to things. Other organisms can pounce on that and use it. It comes out in a chelated form. Anybody heard the term chelated? It just means it's stuck to a bit of organic matter at that point. So this thing is available. Another thing can grab it off us now. So if you go and you do your thing under that particular tree every day or whatever, you might help the tree, okay, if you haven't been eating the wrong things. But the digestion pathway. This digestion pathway ends up with carbon both in the labile form and is humically available. I'm not saying it makes humus, but if you went and had a shit in the woods, the chance of that potentially ending up as humus is now much, much, much higher than if it were landed up coming out of a compost heap. Is everyone happy with that statement? Why? It's because the elements in there are available to do that. The carbon in there is available. It's ready to be attached and utilized. It doesn't all end up as humus, but a percentage of it is available. Okay? Earthworm dung. Now that's a different story. Very highly likely to end up as humus. Okay? Compared to when, lucky it doesn't go to the loo and flush it to the local business. What was the other one I can draw on here now? The liquid carbon pathway is now a different pathway for carbon to cycle in this business, right? With the liquid carbon pathway, a very high percentage can end up as humus. A very small percentage as humus, and you could basically say next to none of the other one. Though there are arguments about it. Have you heard of these people that are now doing what they call silviculture, where they're pushing up humus production out of trees? They're doing it in South America or Central America. To get this to happen, they pollard the trees until they're this big. They near kill the tree. The tree's done it to it 3 or 4 times, the tree shits itself and starts to create conditions for long-term life to survive there. These guys are now harping on this, that they potentially can get trees to push liquid carbon pathways and create humus, which is pretty interesting. But they're the only ones at this stage who are claiming it.
So just a case in point there, along the Muckerwood Creek, there's a lot of red gum saplings that sort of only grew in about 2011 or 16 when there was a bit of rainfall.
Yep.
But they've just taken off and they haven't let go. And it's been a big issue for us when it's taken over the best grazing paddock. We went along and cut a lot of them off, and then they fall out.
Yep.
Right? So it's crazy.
Yep.
And so one of the challenges is what do we do with this?
Yes.
There's a couple of options. One is we turn it into biochar that we use it on the property in a beneficial way, or maybe we leave part of it, because what you're saying is that we're building humus in the soil. I don't understand much about it.
The trees, a tree is going to want to, a red gum is one of the ones that does get on with the grazing ecosystem. It does.
What, sorry?
A red gum does get on and is compatible with a grazing-based ecosystem. Yeah. So you can have really healthy red gum in amongst a really healthy grazing ecosystem. Yeah. But a lot of trees you can't. Yeah. Okay? They're like a normal eucalypt, just couldn't give a shit about grazing ecosystems. It'll just try and kill everything around it in the grazing ecosystem world and replace it with this mulch layer, replace it with visible saprotrophs, and try and push it in that direction. And a red gum will do exactly the same, unless you graze the hell out of the country around it, which will then change the way that ecosystem works, and the red gum will be quite happy. It'll go, and at some point it'll say, all right, I'll give up, I'll just be a red gum in a grazing ecosystem, and I'll be happy as Larry. Grass can grow right to the base of me.
Ron amazed how much grass we get growing under the red gum.
Yeah, they just can get on really, really well. Especially if you've been pollarding them, they'll get on even better with them. As long as, when you do that to them, you're not mowing a thick mulch down to soil surface. Because if you put a thick mulch at soil surface, you'll immediately create conditions for the development of further mold soils, which are woodland soils. They're operating in a woodland ecological process, okay? Carbon is cycling in a woodland style. So you've got to be just a bit wary of that. But I'll give you more explanation of that maybe in a minute. But
yeah,
yep.
So even before you're talking about the exudates coming from the roots, and were you saying that occurs similarly for a forb as it does for, say, a shrub or a tree?
No, shrubs and trees hardly do it.
That's what I want to clarify.
Yeah, hardly ever liquid carbon pathway going on here. The only time that that's happening is they say they're making it happen. And in other words, I haven't been there and seen it myself, is where they are cutting those trees to within an inch of their lives and making them go again, and within an inch of their lives and making them go again. So people are getting it right with a thing like Lucina or Tagus hasty or whatever. They're doing it with that because they cut that tree way down and just keep cutting it down, and that tree eventually responds by behaving like it's part of a grazing ecosystem.
So its relationship with the microbes is very different from a grass.
Yep,
really.
very, very different.
And it's getting a lot of its nutrients from the decomposition at the surface.
It's getting all its nutrition, nearly all, you could use the word all in this circumstance, from decomposition at soil surface. Yep.
Do the grasses have any lignin in them at all? Or?
I got into trouble again, a little rap on the knuckles the other day, because I said grasses live in a cellulose world and they don't create lignin. They do, but it's a minimal percentage. Yeah, this is the lignin world with a bit of cellulose. We're going to grasses next, largely a cellulose world with a weeny bit of lignin in it. But most of the time we refer to a grass as being lignified. It's hemicellulose and waxes that it's made to make it structure a bit more like lignin. But it does have some lignin in it.
So what's the methane being produced by ruminants? What's the...
We'll get to them in a minute probably, but a good plan to pull me up on that. Well done. Net byproduct of the digestion pathway, net byproduct is, we might do it up here, shall we? Methane. The net byproduct of digestion, you produce a shitload of, bad word, Dick, of methane every day, okay, because you're in the digestion pathway. I didn't get your name at the back there, but you're talking about the compost you make when it's getting hot like that, and if you put a plastic bag over that and you could catch it, what would you catch out of your compost heap? Methane. So either of these two routes per ton, more or less the same amount of methane ending up in the atmosphere. Decomposition or digestion. Liquid carbon pathway, no methane. Okay.
So what do we mean by digestion pathway? What is that?
It's been ingested and broken down inside an organism,
Right.
as opposed to external of an organism. In other words, most of the digestion pathway stuff is done through fermentation rather than through acids. Does that make sense? Even you've got an acid in your first stomach, but your main stomach is your hind gut, which is a fermentation process. Okay, the ruminant happens to be its first gut that does the main fermentation job. But single what do we call them? Hind gut fermenters, so elephants, horses, all those sort of people, rhinos, all that mob, they do their fermentation in the hind gut. Ruminants do it in the front gut. The swine and humans who use acids in our front gut use a fermentation process in the hind gut. So we're all fermenters. So I guess the main difference I'm identifying here is the digestion pathway is a fermentation pathway, rather than, and thank you for pulling me up on this, because this is a word that I have been using a lot more to explain this in the current picture. Fermentation versus decomposition. Okay, so you were talking about making compost. You can make a fermented compost, which would be a whole lot different kettle of fish to a decomposed compost. So when I was a kid, all the compost that my mum made for the garden was fermented. It wasn't composted. In other words, it was put in a heap that was never ever turned over, never had oxygen put into it. Oxygen was largely removed from it. In fact, after they'd had a big thing of putting it in the pile, they'd bury the pile with soil to stop air moving. So like making silage. So we actually made silage rather than made hay that's going old, if you know what I mean. Somebody had a hand up. Yep.
So do worms digest with fermentation?
Yes. That's the magic of an earthworm, is actually fermenting stuff in its gut. Yeah. It's a short, quick passage, I understand, but yeah, they're fermenting stuff in their guts.
Fermenting compost.
Right.
So it's anaerobic, is that what you're saying?
Yes. Yeah. And the people involved are called, there's yeasts, bacteria and fungi, right? So in the gut of a beast, 50% of the living thing in there would be bacteria, 50% would be fungi. That's not right, because a whole lot of yeast as well, but those two would almost be equal, fungi and bacteria. But all the fungi we're talking about in there are invisible to your eye and my eye. We can't see these buggers. So they are called facultative anaerobes. Okay, I wrote that down because some dude was throwing that word at me 2 days ago. How cool is that? New word too. I couldn't spell it, but I had 2 goes of it in my notebook so that I would know what I had written down. Facultative anaerobe. So it's an anaerobic thing. Thank you very much for asking that question, because it helps me hugely to remember to put it into this thing. So, yeah, the decomposition pathway we could probably say is usually aerobic, and the fermentation is not. So humans, for example, if it wasn't for the discovery of fermentation, for us Western European ones, we wouldn't have survived without fermentation. Beer is still the most important liquid on earth. It's been keeping humans breeding for about 7,000 years, or somewhere 7 million years, no, 7,000 years. It's not just that, but you know, like the Poms, for example, in the 1400s, had no ability to store grain, except by first making it into grog, putting it in a barrel, because the rats couldn't eat it there. Okay, so all of yours great-great-great-grandpuppies were raised already half pickled from when they were little. Okay.
So aerobic and anaerobic processes, so the decomposition and the digestion are both producing methane.
Yes. Yeah, I'm afraid methane's a dead straight byproduct of any decomposition, fermentation, digestion process. Anytime carbon matter is being broken down, except the one that I'm going to draw on here for you in a minute. Anytime carbon matter is being broken down, it will release methane as a byproduct. The only other one of these, which we haven't got on the list yet here, does anybody want to guess what it is? Australia got all over the news this year about it. Everybody wanted to slit their wrists, end of the world. Oxidation process. There are 2 methods of oxidation. One is really fast, which is fire. Net byproduct of fire. CO2 and methane. In fact, one step worse than straight methane. It's methane mixed with bromine, methyl bromide, which does 2 things. A, it makes methane have a longer shelf life in the atmosphere, and B, it does terrible rapist jobs to the ozone layer. Yeah. Okay, so...
Dick, can I?
Yep, go for it, go question. Yep.
I missed how you got methylbromide.
through the fire, through fire.
Where's the bromine come from out of that?
Oh, I'm buggered if I know. But you can read about it, that it does come out of it. So the Max Planck Institute have some really good, simple, you don't have to read the whole crap in it, but just the conclusion parts and beautiful diagrams of how and when in a bushfire methyl bromide is released. But I don't know where it comes from, I'm afraid.
Is there an oxidation pathway through cultivation as well?
That's right. So this is oxidation. This here is what we would call chemical weathering. Yep. And absolutely, if you turn a soil over, then you're going to have this chemical weathering taking place with that organic matter. So has anybody here ever seen grey plant material? Old grey plant material lying around? Yeah, but most of you have seen it in the old eucalypt that fell down when great-granddad was this big, and it's still lying there. That there's actually chemical weathering taking a huge amount of time to do that, but there is a net output of that to a degree too, of methane. It's just real slow. Okay.
Dick,
Yep.
You got methane, but in the decomposition process and the oxidation process, you get a lot of carbon dioxide going back up as well.
Yeah. And of course in the digestion one as well, because most of the organisms, Tom, as you're pointing out, that are actually doing the digestion are breathing in and out of oxygen all the time, and I believe we're net outputters of carbon dioxide because we breathe oxygen in all day and night, as opposed to a tree that breathes in oxygen and carbon dioxide in sort of equal amounts, certainly if they're at the tropics. I imagine the ones that, like the boreal forests and things closer to the Arctic, for example, they would do a lot more because of the long day length. They would breathe out a lot more oxygen through the daytime. They're actually big oxygen producers, but then come wintertime, they shut that right down. I imagine they're breathing out carbon dioxide for more hours of a day sort of thing. When I read the paper about the oxygen carbon thing of plants, it said that you just don't have to worry about it. Your main producer of oxygen is actually oceanic plants. So like the plankton and all those people produce a heap of oxygen that ends up in the atmosphere. But anyway, yeah, Tom, 100% right that carbon dioxide is a byproduct of all these processes here as well. Yeah. Okay. Any more questions on that particular thing? I think I'm nearly finished with that picture now.
Also, the byproduct of all that decomposition, whatever, is it releases the nutrients that are in whatever is decomposed.
Absolutely. So the digestion, the decomposition, even the oxidation process after a fire, those whatever minerals were tied up in those particular plant matter that was originally there is going to be now released for other people to use. Yeah. It's an important part of the whole picture. If it was all just going to sit there, for example, if all the earth got taken up by trees, for example, it wouldn't matter which plant it was, but all taken up by trees, and there was nobody there to burn it, A, or B, to decompose it, or C, digest it, the atmosphere in the end would run out of available carbon, and it would all be locked up in the plant organisms standing there. So it's very important for this process to occur to keep life operating. We run on the stuff.
So we have a tea break for 5 minutes, just a 12-break tea break.
Yeah, I'd love that. That would be really good. And when we come back, we'll jump into the fast and furious last 30 million years of this thing, which has really taken a hold in the last 7. Our friends the grasses. So Dean asked me just to tell you, like a starter, where I came from. Obviously, I'm born and bred South African. I'm sure you couldn't tell by my Aussie accent I've got, but
Excuse me.
no worries. I grew up in the agricultural world. I grew up in Underberg, in the mountains. We used to farm up there. Later, those farms were sold, and we moved to the Kalahari Thornveld, which is up near the Botswana border, basically, in South Africa. So anybody who's been to Botswana would know more or less where that is. I became an educator in holistic management starting from about 1991. I was probably fully involved in education and holistic management in 94 or so.
Through Alan Savory.
Working for Alan, yeah, not just for Alan, I worked for myself obviously doing the job, but I trained educators for Alan, yeah. And then in the later 90s, I made the mistake in inverted commas, because it was a very positive one, of saying to Alan that some of the stuff that he was teaching and the grazing stuff wasn't necessarily working, and I wasn't getting a good enough feedback from people I was working with to make adjustments to what I was doing. So I needed to go back to my first love, which is obviously farming and working on the land, working with livestock. I would do the training thing on the side. Alan was furious with me, of course, because I was one of his inner circle sort of top-ender people. I was training educators. Anyway, I'm really pleased I did that in the end, because most of the stuff that I'm teaching you now is only developed because I was actually doing the stuff and working out that most of the stuff we were talking about wasn't actually working. I met Christine Jones, Dr. Christine Jones, the famous Aussie, in 2004 for the first time. I brought her out to South Africa to talk at a conference and had her on my place and took her on a tour to visit a whole lot of other farmers in the country, and learned a heap from Christine. Or rather, she opened my eyes hugely, but she just refused to teach me any method. I'll tell you the story later on, but she just said to me, "You'll sort it out." And what you see today...
She refused to teach you?
She refused to teach me any method to make the thing work. She said, "You'll sort it out." And Christine and I have been really close since then. I didn't realise how much of an effect I've had on Christine. I've always sort of like hugely... emotionally attached to how much I've learned from Christine. You know what I mean? I hold that lady in such high regard that, like, if I see her, I'm getting a palm front and sweeping the ground. But I didn't realise how highly she holds me in regard as well. So that's very sweet. I've learned so much from her, and I'll use a lot of her stuff today, have done already, and will do as I go ahead. So that's why we've ended up with a different process to the normal planned grazing, but all the basics of cell grazing and planned grazing are the same mathematics, the same constructs that have created what we use these days as the grazing naturally method. But you still use those same mathematics and methods to plan it. It's just would be done differently for various reasons, which hopefully you'll pick up through the day here today. Okay, so that's my background. So half the reason why I can't spell is because I learned to speak English only at about age 6, and before that I could only speak Zulu, so I can...
Speak what?
Zulu. So if I do an exam in Zulu at school, I used to get 98, 99% for written and oral Zulu tests, and English I used to get a really good score of E for English, which I thought was really good. I tried to convince Mum and Dad. Right, okay.
How did you end up in Australia?
I moved to Australia about 10 years ago when because I'd up to that point promised that I was going to be the one to switch off the lights in South Africa, but when I realised it was just a waste of time.
Switch off the lights?
The lights eventually. I'd be the one who switched off the lights and pulled up the fences, but I decided to pull out and leave it to everybody else. I couldn't see any point of waiting 400 years. I didn't think I'd still be around 400 years' time. For South Africa to one day settle down and be a worthwhile place to live in, basically. Because in the meantime you wouldn't have made it to the point you're in. So, sorry about that. It's a sad sort of background. But anyway, now, in the evolution, am I good to go on? We went trees, shrubs, etc., etc. Then came Forbes, and in the Forb process we now had the first of fibrous roots develop. Now remember, I've left out slimes, algae, lichen, all these other things that went along, not because I don't care, they're not sort of central to my story, right? I've also left out all your main succulents and all these people, although they really fit into this larger Forb box over here. And I'm also going to very lightly slip over what was the first of the people that popped out to create grasses from these Forbs, something called a sedge. Anybody know what a sedge is? So sedges have edges, right? Remember you were taught that once upon a time? So a sedge is the first thing that actually began to grow out of a so you have a plant that's already there doing something, and you have a little bump that occurs on it here, and there's special names for it, but for now we'll just call it something simple, but it actually is a meristem, which means it's the growth point, which can actually begin a new clone of the same plant again at the bottom. The sedges were the first people to do this, and they lived in waterlogged or anaerobic conditions. Okay? And in the process of doing that, you guys all would have seen sedges, wouldn't you? Do you know what I mean by sedge? So, no, I would only come up with Afrikaans words for it, I'm afraid. So, rushes, yes?
We've got a lot of pin rush in this area.
Pin rush is a sedge, yeah. So people who have now a culm, so they can grow these little meristems and clone themselves again underground, you know, so everything else on earth grows very, very fast. Sorry, slow to start with, and then grows real quick, getting really quick, and then slows down and then gets old and dies. Everybody happy with that? As a statement that all living things follow. There's one group of people who do not have to follow this, and that's something called a grass and a sedge. They can live forever. Why can they live forever? They can live forever because they are not an organism, they are a community of clones. In other words, every time this particular organism gets the right things happen to it, it will create the right hormones to make a new little blister, which then creates a new clone of that plant. It has its own little root, yep, and it has its own little leaf system and whatever, and eventually this one can be replaced and died. So each tiller, each shoot has slow growth, getting faster, getting real fast, gets old, dies. But before it does that, it's supposed to create a clone of itself and replace itself. Okay, there's certain things that will drive that process more than others. For example, grasses have evolved with grazing animals. Would everybody be happy with that statement? What came first, the chicken or the egg? We don't really, nobody would know, but the one has led the other one along. And the saliva of a grazing animal has an enzyme in it which drives the production of the hormone, whose name's not here right now. It might return at some point, but it's not in my mind right now. That drives this development of this new little bump over here, which clones the new plant. So, who has ever come across oats plants? Oats? If you planted oat, you put a seed in the ground, how many tillers would that thing have? Max 4, more than likely only 2. So 2 shoots. If you graze that oats, every time you graze it, it'll make at least another 2 tillers. In fact, if it gets a really heavy frost on it, it'll terrify it and create the same outcome. It'll make more tillers. So you can end up with one oats seed giving you 18 or 20 stools, we call them, and where I come from. But here in the things, stools give people a fright when we talk about tools, so we talk about tillers. There's the word, tillers.
Is that a stalk, a tiller?
A tiller is that one little jobby that starts down at the bottom over here and makes its first little leaf out of the meristem down here, makes its first little leaf, which comes up and opens out and turns into a leaf. That there is a tiller. It goes, eventually can go all the way up to create its second leaf. Once the first one's going, you get the next one's already developed here at meristem, which is soil surface or just below the surface. By the time that leaf gets to opening out, the third one is already tearing up inside, which would get up and create your third leaf scenario. By the time that third leaf's getting here, the fourth one is coming up. Again repeated for number 5, again repeated by number 6. Some go up to 8. Others, like maize for example, go up to 12 or 16, but most of them would go around about 8 or 10 leaves when in total, and at about the third or fourth leaf is when the meristem changes over from being a vegetative producer to a reproductive producer and starts to make the seed head. The seed head of this plant is actually produced right here in the meristem, inside the sheath. It's not made up here, it's made down here. That then is elongated and eventually pushed out to become a seed head nodding up in the breeze there. So that one thing is called a tiller. Yep.
If you're grazing that oak plant or whatever, what stage would you put cattle in after to graze?
We'll get to that. Okay, I will get to that. That's what I'm drawing this whole thing about here, is to come to that. So thanks for asking that. But just for now, we'll just pull it up back to principle. But thank you very much. So every time that plant gets disrupted or disturbed, you will have the production of, starts with an R. Thomas, can you remember its name? The hormone, if it's important for us to have the name, which creates this new little bump on the plant here and has a go. So I had a little experiment at home. I had bought a place down in the Adelaide Hills that was scrub all the way around it, planted right to the door. So I got my skid steer and I pushed all the scrub out because I obviously didn't want to be burnt out of that particular house. And I put a bit of straw there because it's non-wetting sand. You guys know about non-wetting sand? So when you go for a wee, you don't just have like a wee, you've got to be right, ready on your toes if you're going to have a meter service from one of those flash service type blokes, you know, and you've got to be ready because when you wee, it takes off like a black snake across the pasture because it won't go into the ground because it's non-wetting sand, right? So I put a bit of wheat on it, a bit of old wheat straw, not much because I don't want to create a woodland scenario, only put a little bit there, and then I put some wheat seed because there was some lying around for the poultry, and I chucked that out there, and I watered it. The first time I watered it, it took 5 minutes and the water was already running off because it's non-wetting sand, right? Anyway, eventually I got it so that I could put on an hour's water at a time with my sprinkler, which I did measure with the rain gauge there, but an hour before it would run off even, which would be 36 mils. And that's pretty good that it did that. And it did that within a period, and it's a longer story as to why. It's back on the other page, you saw it just now. But it did that over a period of like, say, 4 or 5 months. I could already put on 36 mils onto it. Anyway, the point that I'm telling you here is these are wheat plants, which is an annual. But I mowed it every time it got that tall. I mowed it like a lawn, cut it down, mowed it like a lawn, mowed it like a lawn. 18 months later, when I moved out of that house because I sold it, the wheat plants were still alive, 18 months old. They were tufts this far across at the base, and they would still tiller and make new babies across the entire thing every single time I mowed it.
When you say mow, were you cutting or grazing?
No, lawn mower, because it was right there in the garden. The potty lambs would get in there once in a while, but this was just with my lawn mower there, and I wanted to have a bit of a green patch in front of the house. Yeah. Isn't that an interesting story? So potentially, I might have been able to keep those wheat plants alive, because remember, I'm watering them, so I might have been able to keep them alive for however many years, 30 years or whatever. I might have been able to make it into a perennial. But if I'd let it set seed, what would have happened to it? It would have senesced and died straight away. Okay, and I'll explain a little bit more about that in a minute, but as soon as if I'd let it go from vegetative to reproductive, I would have lost that plant.
That's part of the strategy with grazing plants, so that you hold back that senescence stage, isn't it? You keep them at vegetative stage.
Right on the money there, Dean, and I'm going to explain how to do that in a minute. Yep. Okay, because there's a whole lot of important stuff going on here. But the principles that I wanted you to get from this is that a grass plant A can live forever. A perennial grass plant can live forever. It breaks the law of young, middle-aged, old, death, gone. And is everybody happy with that statement? And I don't care whether it's a runner grass or a tufted grass, same rules applies. Obviously annuals, they're not going to make that for long term unless you really buggered with their brains like I did with that wheat plant, and I don't know how many years I could have done it for, but still 18 months with probably 4 or 5 months of that total being above 40 degrees is pretty handy job with day-to-day lengths of whatever we get to down there, 15 hours or whatever it is a day. I know it's bloody long in the middle of the summer anyway. Okay, so that's the principle I wanted to cover here. What I want to cover back here now, though, is how these grass plants operate. And I'm going to jump now between these two pictures. So, above ground, what happens to the living material above the ground to a grazing ecosystem plant? In this case, we're looking particularly at grasses, is that this stuff gets removed through the digestion pathway. Okay? A. B. The carbon cycling of it is therefore mostly through the digestion pathway. If you have a thick litter layer at soil surface around these grasses, you have conditions which you are encouraging of visible saprotrophs, ectophytic saprotrophs, which kill and eat the roots of the grass plant. Have you heard of dieback in Queensland, where millions of hectares of the top production grassland in the country is disappearing? It's dying because there is too much old material at soil surface. Where that stuff is grazed hard near the water points, it is not dying. There is no dieback in the heavily grazed areas. Okay? Grasslands, and I'm now going to change to a new term, not talk about grasslands anymore, because grasslands are not pure grass one end to the other. They have a heap of forbs and some trees in some cases, not all cases. Most of southern Africa is totally treeless, was always treeless, will never ever grow tree. Elaine Ingham can take that. It's never going to grow trees, never would have, cannot. Because it is so grazing orientated as an ecosystem, trees cannot even germinate and begin to grow there. They will not germinate. They'll lie there for the next 400 million years waiting for their chance. The only trees that really grow on the Highveld are eucalypts imported from Australia and planted there, and you have to chip it away around it to get it to grow, and then you've got to water the bastard and look after it and mulch around it and all the rest of the things that trees like to get that tree to grow. When they're big, you'd be shocked at how big the eucalypts are there. I've seen a spotted gum where 11 men, I'm using that word on purpose here because they've got that longer arm length, right, standing like this around a tree, can barely get around that tree's trunk. And it ain't hollow on the inside. It's still standing like it's taken heaps of blue tablets. It's about as strong as anything. Okay? So it's not a woodland type of scenario, and I don't want to use the term grassland anymore because I'm going to get into trouble. It's a grazing-based ecosystem. So it's an ecosystem that is driven by grazing organisms.
Is that the whole co-evolution context?
Yes.
With the grasslands and the animals?
That's right. So 30 million years ago, we suddenly came out of the dark ages of this period, and we had the evolution of grasses begin. By 7 million years ago, grasslands, grazing ecosystems, because they had heaps of grazing-orientated forbs in amongst them, were holding nearly all the open land country of the earth. And they did it with huge numbers of grazing organisms in amongst them. So is everybody happy with that? About 7 million years ago, they had that. Over the last 30, it took to develop it. In that period of time, more or less, as a general guideline, because we changed from decomposition to digestion, and the liquid carbon pathway is what really took off once we had the fibrous roots occur this way. We took atmospheric carbon levels from 0.16 to 0.04% of the atmosphere, and we plugged it away into the ground, and we created our humus-rich soils, which we know today. How many years can they plant and produce crops on bulldozed and burnt Amazon rainforest? 2, 3, 4 years, they leave it again and they burn a new patch. because it's absolutely, to use a good Australian term, it's completely rooted. Why? Because they started on country that had very little humus in that country, very little soil structure. 200 and something years after the modern discovery of the American prairies, they are still growing maize cheek by jowl on what was a humus-rich, deep soil, and there's still humus in that soil. 200 and something years later. It's not Christmas time, the top of it, because it's been ploughed and turned and blown and well-rooted. But down below that, those things still get their feet down into what is an intrinsic structure of a grazing ecosystem soil.
That only took like 8,000 years to develop from the Ice Age too.
Yeah. How quick was that?
Inherent grasslands in Australia?
No.
It's not.
They're not, and I'll explain why in a minute, but that's such a wonderful question. And so hang on to that one. I'm sort of jumping around a little bit. This is what Dick does, but it's all logical in the bigger scheme of things, so live with me on this one. What was I going to write here? Oh, principles to take home today. The number one principle of ecology is that form follows function. And I don't know who the first person on earth was who said that, but I got it the first time, heard it from a fella called Ian Mitchell Innes, who actually, no, I wouldn't, I already heard it before I came across Ian, because I read a book by a fellow called Lassiter, who were the developers of the Beefmaster breed of cattle, and that was their number one fundamental process they used to create the Beefmaster breed, was that form would follow function. They ignored defining what the thing must look like. They defined what it needed to do, and they concentrated on the doing and let the form of it come about by its own outcome. This is how nature evolved. The functions happened, the grazing ecosystem, grazing-based ecosystem evolved once we had the development of these highly cellulose, very digestible organisms there in the plant kingdom, who could capture the carbon and feed it to a massive grazing community above ground. They dunged and urinated it into the ground by pushing very strongly the digestion pathway through this fermentation. And because they had evolved these fibrous roots, they drove the liquid carbon pathway and the development of these rhiza sheets, which fed and developed a living organism population around it. So in other words, this is a root system that we've just dug out the ground where the roots look like dreadlocks. They're not just roots, naked roots, they're roots that have the dreadlocks stuck to them. You would have heard about this from so many other trainers in this lovely training program you guys are on, about the dreadlocks around the root systems. These people do it where they can, when it's not just straight waterlogged. These fibrous rooted forms, some of them can do it to some extent as well. But this is liquid carbon pathway going into the ground. And in this process, we changed, me being being one of these people here involved in this process, so this change of plant kingdom and change of the grazing, the animal kingdom above ground, made it the conditions so different in that soil that the saprophytes, these ectophytic saprophytes, had to evolve and become endophytic saprophytes. You've heard of mycorrhizal fungi? You have? However we spell that chappie is one that really beats me always. So the mycorrhizal fungi, right, those people, they are endophytic. So although they look the same as these molds here, they look the same as them, the end of every single tentacle is inside the root system of a plant. It is actually living inside the plant. And, surprise, surprise, they are totally invisible. Very different to your visible people over here. They are invisible. This smelled like a mold. This smells like Soil. A beautiful smell of fresh rain if you open a good soil. It actually smells like rain coming. What's that stuff called? Petrichor. Such a cool thing when you drive out of Adelaide and you head west. You go on the old highway and you get over the hills, Adelaide Hills, and you're heading down towards Murray Bridge and you hit that rain shadow, you know. There's a little block there called petrichor, because they don't get any rain, but they always smell the damn stuff somewhere. Yeah, right. Because it drops off an inch a mile down there, you know, and these poor buggers get 120 mils, and the people up on top of the hill are getting 700 mil, and they just smell that rain, but they don't ever see it. Okay, so that is the lovely smell of the mycorrhizal fungi. Mycorrhizal fungi.
The mycorrhizal fungi are endophytic.
Yeah, and they're actually... The H is in the wrong spot. I think that is an O-R-H, or I don't know, I spell it wrong every damn time, but...
Endophyte.
Yeah, it's an endophyte. This is so important because, yes, we do get some ectophytic fungi here, which live outside, absolutely. We do get some endophytic fungi at this end, but the larger part of it is that this is ectophytic, free-living outside, and this has become the insider trading, the government insider deal. Yeah. So what the plant does is it says to mycorrhizal fungi, it says to you, I need a selenium. The mycorrhizal fungi says, sure, Bob, that'll be $10. So it shells out $10 of sugar, gives it to it directly, and it's insider deal, so we can whisper this to each other. Nobody else needs to know this, by the way, because she's going to make the money out of this airfield now, not the other people here. This is cool, so this is what we'll do, right? And then you go out there and you fetch it from someone over there who's got an excess, and that could be 500, 600, 800 meters away, to bring that back to give to me, and I'll pay it to you though. It's an insider deal. The conditions outside of that soil, outside of me, are actually a bit difficult for you to handle. So you live half in me and you do a deal. You've got your other end of you stuck in here, stuck in there, stuck in there, stuck in there, and we can trade. Gets dry. That lovely lady there's got really, really long, deep roots. She's still got a little access to moisture. You can't reach it anymore. Chaps, I'm dying of thirst here. Send out a call. We'll pay us a little bit. We'll ferry it for you. They bring the water from that person and give you a bit of water to keep you happy. Yeah.
What's she paying then?
Sugar.
Sugar.
Basically sugar. So liquid carbon, or, you know, it's a carbon-based thing, so it's a sugar. We can call it a sugar. If it's carbon and oxygens and hydrogens, we loosely use the term sugar for that. Okay?
They can take up to 20, well, they don't take it all, well, they do take it. 20% of the plant's photosynthesis goes to the mycorrhizal fungi.
Now, trees, what's that fungi called that sits on the outside of the...
So, this, I'm actually confused whether it's a genus of fungi or whether it's a family of fungi, right? Because a fungi is a kingdom. So underneath that somewhere, there's a group of them called saprotrophs. That's what the word that I wrote over here.
No.
So the saprotrophs.
CTO is there.
Ecto.
Oh, ectophytes.
Ectophytes, right.
Yeah. So all that ectophyte means is it lives separate to, loose of, or outside of. Okay. So these people are visible and they live outside, that's the key differences between them. Again, it's not 100% true to say there are no endophytic fungi here. But this is a grayscale. It's largely like this and largely like that. Largely lignin, largely cellulose, largely grazing in terms of the digestion pathway here, and this is largely decomposition. So it's a largely to little and little to large sort of picture. Okay? Yes.
Coming to smell.
Yes.
You mentioned that the rainforests have mould smell.
So if you're digging around at the top of any forest, you'll have a mouldy smell.
But the grasslands smell more like rain.
Yes. So you should smell no fungi, mouldy smell in a healthy grassland.
Okay, so our forests here, when I've done a lot of hiking, they smell like rain. They don't smell like mould. So are we looking at grasslands with a few trees that we're calling...
Potentially. Very, very likely. However, did you scrub around in the...
No, because
Okay.
it smokes.
Yeah, right. So if you scrub around there like a bush turkey,
Yep.
that's when you'll get the mold. Okay? So we're talking about in the soil here itself. If it is a grazing ecosystem with trees on it, then you wouldn't get that fungal smell. Unless you are right under a tree within the drip line, within the litter drop sort of layer, you might get it under there. Especially anywhere where there's a mulch. So anywhere,
Inhibits the grass growth.
that's what inhibits the grass growth. And where you do get grasses, so if you headed west of here and you eventually went through the mallee country, you'd see where they've opened it up and they graze in between, but they've left strips of mallee. There's the odd grass growing underneath them, so you do get some grasses there. But when it's bone dry and they're stocked in that same paddock, there'll still be green leaves of grasses underneath those trees. Why? Because the animals won't eat them. How strong has that stalk got to be to hold that thing up there? There's a lot more infrastructure goes into it. You will never ever find in the dung pat of a cow, sheep, goat, elephant, you will never find any remains that you can identify of leaf 1, 2 or 3. But you will find remains of leaf stalk 4 seed head. Invariably, right across that board you'll find it. You'll find the remains of leaf 6, 7s. Because the infrastructure that's going into that is bigger. By the time we've changed from our little dinky toy tractor to building a room this big, look how many hours of labour and how strong these walls have got to be to hold that roof up. Do you see the logic behind this? What is the expense of building this thing in terms of energy compared to the little job? It's huge. Can you see what I mean by that? So in other words, it costs the plant more to produce the more aerial stuff. Okay? And that's just the materials we're talking about to hold the stuff up.
So that sort of runs obviously counter to the long rest period idea where you've got much greater growth if you right.
Probably. And this is just the first one of these chops I'm going to throw into this synagogue. Yeah, the pork chops I'm going to throw into the synagogue. So first one is digestibility, but you can read that in any grazing manual anywhere. If you found that graph, you can find that graph there. So it's a known fact. Okay. So, and it hasn't quite flown in the face of that yet, but it's quite interesting that it might. Yeah. Righto. So what happens to the sugar flow now? What is it that operates this sugar flow line? And what we found, and this is Christine Jones, coming out of her mouth, not coming out of my mouth. The moment the plant changes its growth from vegetative to reproductive, sugar flow stops. The plant can no longer afford to spend the energy on getting its house built right. Its house being the soil within which it lives. Because remember, we're talking about grass plants here. We're probably talking about a perennial grass plant. Where does it live? It's an underground plant. It lives in the ground. Okay, where does the tree live? The tree lives probably above ground, much more than it lives below. But a grass plant actually is an underground thing. You can have grass plants that are this dinky with root systems yay size. Okay, it is absolute bullshit. So this one is like the big, this is the whole pig going into the synagogue now, loose and greased. That, what was my... That what is above the ground is a mirror image of what's below the ground. Tree, yes. There's got to be a relationship of size above to somehow hold itself up with below ground. But grasses, no. There's this lovely dinky little Daniel. He's probably about this big already. From a station in the Burdekin Valley, sort of inland from Bowen. He comes to the field days all the times with his parents, big hat on, buckle, and he stands like this at these days. He's a beaut kid, very, very beaut kid. So at one of those field days I said to him, Daniel, man, why don't you just pull out one of those little grass plants for me? And it was around this anthill set stock paddock, anthill, obviously where there's more mineral, it's sweet, the cattle live on those little things. So these grass plants are about yay size tall. And he's got a hold of this thing, and he's just leaned down and he's sat through cell grazing, RCS schools, grazing for profit schools. He sat through holistic management schools. They had Roger Savory staying with them in their house for like probably 3 months of total time, if you want to put it together, with him bothering them there. He got this thing and he's trying to get it out. So he starts to, I said, no, Daniel, you're not allowed to twist it, turn it, or yank it from side to side. Just pull the freaking thing out. Don't be a little pissy, I said. So then he's got 2 hands on it and he's giving it the full. He cannot pull this little bastard out of the ground. And I promise you, it is only this big. So then Cruel Dick says, oh, don't worry, mate. You're too light to get that thing out. Grab one of those big ones there and pull it out for me. What does Daniel do? And he gets hold of this big bastard, straight on his back. Flat on his back, no roots. I'll write you a letter now. You guys are welcome to write back. Business card here with email address. Pamphlet there with email addresses. My one with email addresses. Don't forget that you can buy one of these later if you want. This is out of date. Dick wrote it ages ago. It's about holistic management, but it's still a good read, and I've got a couple of thousand I'm still trying to get rid of. Okay. $20, change in there, fill it in. If you don't have cash with you, drop me an email to say you took one. Please take it. Drop me an email to say you took one, and I'll call the cops. No, I'll just send you an invoice plus GST on it, right? So please help me with it. They're more in the car, they're more in the box down there, so just help yourself. Where was I? Writing you the letter, wasn't I?
The 2 different grass plants.
Yeah, I'll write you a letter that you'll go home and you'll find fully grown out grass plants nodding away in seed, the kind that you would take a photo of yourself in. Do you ever see photos of regenerative farmers in the land without the seeds there? They took those first ones of me when I came to Australia. I had to lie down because my grasses aren't all standing looking around in seed. I don't need them to get there because they ain't healthy. You can go and pull out those plants that are standing up in seed. You will pull them out. A little overgrazed grass plant like that, you will not pull it out unless you manage to twist and pull and hurt that little thing. It's not a mirror image above and below ground. Okay. So the root system is pumping up, and it's pumping sugars into the ground from 20 minutes after the graze for leaf 1, leaf 2, leaf 3, leaf 4, 5, at 6-ish somewhere, as I said, 6 to 8, 5 to 8, somewhere there, that grass plant begins to, the meristem shifts from being vegetative to reproductive. I better rewrite those because intrepid leader Dean is a bit colorblind and can't see the green. Reproductive versus vegetative 18, right? And it's going to happen at about there on the plant, okay? And when that happens, the meristem makes the seed head. And this was fascinating when I first heard this from Christine Jones, and it was kind of a dumbass. You always knew that. But the seed head is made here, at the bottom. It's not made up there. It's filled up there, sure, but it's actually made here. It's got to grow all the way up to there. And you think of a good example of a teenager. What do they do with most of their day if they were given the chance?
Sleep.
Just lie there, sleep, sloth, scrubby little bastard, whatever words people use to frickin' thing, get out of bed, or whatever they try and do for these people. What are they doing? They're disinterested in everything until the hormones turn on. Then suddenly it's organising roots and grazing and all that sort of stuff out, trying to get out there and get busy. The reproductive stage steps in, and it's a totally different organism and beast you're dealing with. Okay? Same thing with the plant. If the plant now has energy to expend, what's it going to spend it on? It's going to spend it on sending its children to boarding school, which is getting this little bugger to there, get it up, put the energy into constructing this tall infrastructure to get up there, even go as far as creating lignin to try and give it enough strength to stand up there. By the time it gets up here, it's got to push fats, oils, whole lots of secondary foodstuffs. I can't remember all their names. Lipids, all these things it's got to put in to make that thing. How much energy does that cost? This part of a grass plant is cheap. Like the first few years of a little baby's life. What does it need? It needs a clean bum, warm bed, and really just a bit of breast milk, and the thing's gone. It's dirt cheap. Compared to when they go to boarding school, they're getting a whole lot more expensive. And when they go to uni and they start getting people pregnant and all the rest of it, and need writing off cars and spending nights in jail because they've been driving under the influence, that's expensive time. Does everybody follow the logic of what I'm talking about here? Okay, excuse all my stupid stories that match it. But that's when it becomes very dear for the plant. That plant no longer has spare energy to expend on this job underground. It will push a little bit of sugars down. But these lines are not black and white. Remember, they have a grey shading. Just like the picture of mine of the tree community through to the grassland community, it's a changing thing from mostly endophytic to mostly ectophytic or whatever. Do you know what I mean? Same here, but the sugar flow more or less stops the moment the reproductive thing happens, and that happens down here, and it happens, different species, you can go and look them up, but it's more or less 6 to 8 leaves height. So yeah, go on.
Theory, if you always had a grazing, so that at, vegetated stage, always grazed, how would those plants reproduce?
They don't need to. No. Some stage they do need to. Yeah. At some stage. And we'll build reproduction in here. And I'll explain why we build it in, and I'll explain how it happens automatically. You can't help yourself. Okay. That. Do you see that? The little safari squash beer can. That's what we have to teach people to do. And I used to work in the safari industry, so I had room to take all the empty beer cans home. That is about where an animal would graze a grass plant to. About that. I know that we have a lot of southern region people present here. So you might have, in more southern regions, you might have animals happily eating plants to where you can see a golf ball in the paddock. Okay? Is this unnatural?
Heat on the soil surface up to 55 degrees Celsius is, to me, unnatural.
Okay, convince the animals that. Because within 10 minutes of me turning a mob of cattle into a paddock, the first grass plant is this tall.
The what, sorry?
The first grass plant is this tall. Go and tell it to the animals. Because I've tried. I've spoken to thousands and thousands of cattle and sheep. I've discussed this thing with elephants. Have you ever seen an elephant eat a grass? They wrap their trunk around what they can get hold of. Like that. They wrap their trunk around it. They take their front foot and they kick at their trunks until that grass plant is shaved. They pick it up, stick it in their mouth, get the next one.
Do they uproot it, you say? They don't?
Some roots might come out here and there, but no, they actually want the leaf off it. That's why the kick is so importantly done to get it out, to take all the plant material off there. Run up to that elephant and say, you prick, what have you done to that grass plant? You're only supposed to eat the top half of the grass plant. What do I get?
Kicking the bone.
Oh yeah, piss off mate, go away. The one day I got to a place called Etosha up in northern Namibia, and there were 70 giraffe. I counted them. They were all out in the open, front legs open wide, heads down going like whippersnippers, eating grasses. They were eating them so that genuinely the height of the grazed grass was only as tall as the sole of my boot. I said, what are you people doing? You obviously browsers because you don't know anything about how to look after grasses. You're only supposed to eat the top half. Giraffe just says to me, mate, do you know how much energy I've expended getting my head down here? I'm not wasting only eating half the plant and then have to do it again. I'm eating everything I can damn well reach down here. So Christine Jones and I have had, since 2004, the one thing we have continuously squabbled about is the eating of the grass plant. She says animals will only eat the top half of the grass plant. She says it until 18 months ago. That's what she always said. They'll only eat the top half of the grass plant. Because, Dick, we have proved this 100 times over. The top half of the grass plant is 2 times as nutritious as the bottom half of the grass plant. Therefore, the animals always select the top half of the grass plant. I'll say, well, Christine, come and talk to my cattle. Come and talk to my sheep, because they don't fucking know this. They graze the whole grass plant when they get to it. No, Dick, they only eat the top half. We've proved this. I say, well, I've managed to get it right twice in my life where the animals would eat only the top half of the grass plant. One was on a monoculture of Schmittia kalahariensis, with a density of cattle at like 250 or 750, I forget what it was now. It was a pretty high density for me in the Kalahari Thornfeld, and I managed to get them to do it. Big, proud of myself, big. Once. The other time I got it right was up near Burua on the southwest slopes. I did it with my 850 shorthorn cows, plus their calves, plus their bulls, in a 5-hectare paddock, doing 3 moves a day. That's why I was drinking so much, because I had to go to the pub to keep me awake at night to come back for the nighttime move, right? Those cattle in a completely monoculture situation of a ryegrass, they ate the top off that ryegrass only. Only 2 times in my life I've got it right. And I keep having this argument with Christine. Last June, all of a sudden, Dick, you say it happens only in a monoculture. I said, yeah. She said, well, we've done the test, she said, with 32 different species planted, including many forbs, and the animals take the top half of all those plants ahead of eating the bottom half of any of them. I said, well, mate, in a natural wild state, that doesn't happen. And she suddenly just jaw dropped. She worked it out. She said, every time we've done those experiments, we've planted the pastures to run them on. Every single plant is the same age. In what I call wild grazing, which is the stuff that I deal with mostly, it's not planted pasture. It's not everybody standing in of straight lines of 1 row of this and 1 row of that, or 3 little oat plants and then 1 veg. You know what I mean? This is wild stuff. That plant is 65. That one there is 650 years old. That one is this year's baby. Each one's a different age. Each one's in a different physiological state. Each one is in a different mental state. Each one is doing something different. This one is sitting on, just underneath it is a dung pat that was dropped on the perfect weather conditions last year and taken by dung beetles and buried just there. You're living in paradise on that dung pat. This poor girl here happens to be in a spot where there is no mycorrhizal fungi coming to anybody, from anybody. She's in a bit of a poverty-struck spot. She's taking ice on the weekends and she's not very comfortable. Who wants to eat that? So everybody eat the top half of this one. Now, what's the most palatable thing? Woo! The bottom half of this plant is more palatable than the top half of that one. And Christine just absolutely ticked. I understand now, I've got it. So, you don't have to eat only 30% of the grass plant. Stop sweating it, stop worrying about it, let the animal decide how much, what they want to eat out of that plant.
So that's the message really, watch what the animal prefers to do.
Yeah, just let them eat it. They'll eat them to the ground. I promise you. I remember the one time, ride a horse into that paddock with a mob of cattle. I've got the dogs. I pull them up. Everybody's settled, got their heads. I rode down to the bottom of the hill, checked the floodgate, needed a bit of fixing, whipped the rods off so that they wouldn't get wet, hung them on the pommel of the saddle, tied the horse up so it didn't piss off with my pants, waded out into the creek to fix the thing. And really, as long as I'm telling the story, is how quick this took. I got waded up out of the water. There was the first cow, grass plants this tall. Genuinely, this golf ball of mine is a joke compared to how heavily that particular animal grazed those plants there. This is longer than taller that way than those grass plants were left behind. And that was within the first 10 minutes of me turning those cattle into that paddock. Nobody on earth can tell me the animals will eat only the top half of a grass plant.
Does it matter how brittle the environment is?
Nothing. In fact, the more brittle, the more selective. And the more brittle, generally, the more sweet the plant, the more intensely they graze it closer to the ground. You go up into the humid tropics, animals won't even graze a grass plant lower than that because of the mouldy, shitty shit going on at soil surface. This is standard. You get down into your part of the world, especially where it's a bit dry, mate, they'll graze it down to this. Anybody here see anything different, you let me know. Okay?
So, Dick, what we're hearing is that this notion about the 50% sun is pervy.
Can it? Absolutely can it.
And so the animal wants to eat and happy, prefers to eat short.
Yep.
That's where
yes.
It tells us it knows what's good for it.
Yep.
Then you've got the question, if you do that and then put it in the paddock, then I'm sure you're coming to this anyway.
Yep.
And then, depending on the season and everything else, you'll bring it back into that paddock at some point.
Yep.
You watch them count the number of pillars, you got to say, sense whether it's in the vegetative stage or
yep.
hopefully not the senescent stage.
Yep.
So you'll use that to inform your decision about when you bring the animals in. And
correct. Yep. I'll lead you through the decision making on that shortly. But what's interesting is that if you graze the plant when it's at the right height, you do eat 50% of the plant. Wow. Look at that. Animal will love it when it's that tall. Highest sugar content, best tucker, best performance, and that is about 50%.
Is that across the board, all grasses this applies to you?
Oh, baby, all of them. within a variation. Those Kiwis giving me a heap of grief the other day because Dick, the ryegrass is mid-calf tall and it's only 2 leaf. Right, that's New Zealand. Everything's bigger and better and stronger hakas there, obviously, than we have. Like, this 60 kilos are genuine. You won't find a growth rate of much more than 60 kilos dry matter per hectare throughout this region on all the pastures from space history. So, if that's the case, you're getting to this, you're already, that there is, if that's what's standing there, that is 1,000 kilograms of dry matter per hectare of grazable feed. That's a pretty heap. At 40 to 60, it's only a few weeks and it's done that. Yeah. Okay. Well, less than 14, 20 days it's done it. Righto. So, yes, we can get them to eat 50% if it's nice and short. So we can win both sides of that little argument. Okay? Right, Christine Jones comes to visit me in South Africa in 2004. I'm very proud of this thing that I've organised, this conference. I've got it 100% right, the right time of year. It's April. My paddocks are looking perfect. They've all got seed heads on and they're nodding in the breeze. I've got my 120-day recovery period. I've got this thing sorted. I've got my graze plans for every mob. I'm like, mate, I've got my zip open and I'm just showing off as much as I can. I take Christine into this paddock. Look at this, Christine, what do you reckon? And she says, yeah, right. So what are you waiting for here, Dick? So I get my stock book, page to this mob of cattle. Those cattle are up there in that paddock at the moment. Another 2 days, then they're going to be in that one for 4, then they're going to be there for 5, then there for 3, and then they'll be here. Come on. Christine's the most irritating freaking woman. She just kicks away. She's got this irritating little she chucks in there. She promises when I tell the story, I tell it personally very wrong. But anyway, she tells the same story, but obviously from a different, she watched a different movie. What are you waiting for here, Dick? Right. Christine, those cattle up there for this many days, then they're going there, and then they're going there, and then they're going there. I want my pat on the back. So what are you waiting here for, Dick? What are you waiting for here? Fucking make him dumb down there. Christine, they are, cattle are up there. What did you ask me? She says, what are you waiting for here? This is in 2004. What do you mean, Christine? She didn't have all this detail. She didn't understand half of the stuff we're talking about there in 2004. But her words to me were, Dick, this pasture's already finished doing what it wants to do. It's all going reproductive. It's all producing seed. The nutritional value of it's dropping off. It's no longer feeding the soil like it should. Its root exudates are dropping right off. What are you doing? Says I. Christine, but the 3 paddocks between here and that mob of cattle also need those cattle there. Yes, they do, Dick. And thinking about it, Christine, the next 20 paddocks, in front of them, if they get here, is also already at the stage, yes, Dick, that's right. So how do I manage this? You'll work it out. That's what she said to me, and that took me a long time to work it out, actually. But anyway, on the way back to the vehicle, Christine stops. Now, this conference, we're running a grass rally and we're doing a whole lot of things with it. No, I can explain what those are later on. But anyway, we're loading the conference goers, there are 400 of them, into cattle trucks, and the cattle trucks go out into the paddock down the 2-wheel tracks and take people on the field trip part of it, right? So because I don't want anybody's radiators getting full of seed, I've taken a slasher and I've mowed the middleman, what do you call it, between the 2 tracks, that little mound thing with the seed grass on it. I've mowed that, and I've mowed an out and a back with a slasher on each side of the track, so there's no grass seed there. And we walk back to that, and she says to me, Dick, when did you mow this? Like this, not noticing what the hell she's really on about yet. About 2 weeks, Christine. Yeah, right. Look how much it's grown in 2 weeks. In 2 weeks, that stuff was like this. And what was the colour difference between it and the rest of my plants? What was the colour difference?
Greener.
Max this sort of colour to that sort of colour. Genuinely, how many paddocks do I go to where people are running 120-day recovery periods, 200-day recovery periods? That's the greenest fucking thing they can grow, and their place is about that green. Half of them, that's about as green as they can get. What happened to these poor animals? They spend their whole lives on a half-assed attempt at a feed. And to fix this problem, what do? Long recovery period, it needs big trample, doesn't it, to fix it? So what do we do now? We put these poor buggers of starving animals into this massive stock density to try and get this trample. And we tramp more material down on soil surface, which is again shifting the community of organisms back to this end of the scale, right? And to think of it from an economic perspective, where's the cash in animals eating feed that it can't grow? A mob I went to in Gippsland, probably 5 or 6 years ago now, because they have changed the way they run that business entirely. They were getting that training from someone well known in Australia, telling these guys they needed a 270-day recovery period in Gippsland. They did that. They had this old feed like this. It was drought conditions. They had their zips out, profiteering to everyone how clever they were, because they still had feed when some of their neighbours had started feeding. The neighbours had turned over 6 or 8 stock animals in that time. They still had the same old freaking skinny cows walking around the paddock 300 days later because the nutrition was so poor. We had 36 mils of rain that night. How much moisture was in the soil? 0. Why? Because the mulchy thatch layer had caught all 36 mils and none of it had got down into the soil. Your great-great-grandparents lived in fucking thatch cottages. They used mulch to build thatch roofs to stop the water getting on them. This is what these poor blokes are doing. So these stock are battling in that environment. The first time I came to Australia, the time I went to the Pete and Karen and then ended up down in Victoria on this trip, I gave this talk there in a shearing shed. And one of these blokes walked in, and I've worked as a cowboy in the US, so I know what a bull rider looks like, right? This bloke walks in there, he's only about this tall, but he's got the classic bull rider walk. You know, I've been strapping his hand to bulls for the last 20 years and stretching all the ligaments in his arm so that this one hangs, right? Except there's something that doesn't gel. He's got these little girly frilly things on, like this lovely lady's got on her boots. These little, what are they called? Seed guards? Yeah, seed guards. So he's got lots of seed in his paddock. How's that for a guess? Shorts and a cap. If he was a bull rider, surely he'd be wearing the buckle to prove that he was a bull rider, so that we could all say, oh wow, where did you win that, mate? You know? So something doesn't quite gel here. What do you reckon I discovered he was? What was his business? What was his job? He was a farmer. He was a farmer near Albury. What was he doing that had given him this?
The hills.
It's flat as a freaking pancake there. What was he doing? He was a professional fence fucking roller-upper, eh? He was killing 20 to 30 kilo rolls of wire and rolling it up so that when he walked, he even walked like this. Because he was bugging. And he's moving those animals 7 times a day because some person has told him he needs this massive density of animals to trample all his food down to create a woodland and give cattle shit feed to eat all day. I rushed up and hugged him and gave him a kiss. It was before coronavirus days and we were allowed to do that sort of thing. Anyway, I reckon I saved his life. I saw him about 4 years ago. I went down to that same district, that lovely fellow organised the trip, I forget his name, and I went down there and I gave a talk at the shed, in a shearing shed. It wasn't the one I was in the previous time, but in the shearing shed. And I went out at Smoko to have a wee behind the shed, and there were just piles of old wire and what's that stuff, polywire stuff, all knotted and crap lying there and amongst all these reels and tread-ins, big pile of it. That's what I weed on, and then went back inside, and it turned out that this lovely, sprightly, happy young man about this tall with his cap on and his frillies, walking straight, he'd spent a couple of grand on a chiropractor. He was right. He was no longer doing this because Dick had said, if you're moving your animals every day, you're an idiot. You really don't need to move them every day.
But Dick, if he had say a 50 hectare paddock and he's putting in 200 head, is there any point in splitting that in half?
If the graze period's long, split it in half.
So there is some value in reducing the size.
As I said to him that day, mate, don't do that. Go and get the 200 of there and the 200 there and put the 600 of them in the 50 hectare paddock.
Yeah, but if you haven't got an option for that,
then use a bit of temporary fencing, it's cheaper, all the rest. But please don't make that a job.
No. Yeah.
Even the Greg Judy, who's written a book and everybody's doing it, he doesn't move a freaking temporary fence anymore. He's not that much of an idiot. And now he says, oh, I fixed it, I don't need to do it anymore. Little bells going ting-ling-ling-ling in my head. Yeah. Every time, sorry, just a moment there. Every time you drive towards a high stock density type of picture, what is your reaction going to be? You're going to A, drive these processes here, sugar flow through both the trample and the graze effect. But if you trample down a lot of material, you're immediately going to create the ideal conditions for these people to operate. Okay? You're then going to follow it up with a long recovery period. Why? Because the trample effect is going to have caused a pretty high compaction situation, and you're going to be looking at it and say, oh my gosh, I've damaged this, now I need a long recovery period. So you then use a long recovery period, which makes the conditions worse again, away from the grazing ecosystem or grazing ecological process set up over here. You move it this way, and your animals don't perform.
So, in a growing season that you haven't got enough animals to even, is it better to just put them all in the paddock, but they may only eat 60, they might eat 40%. You still better to move them on to the next bit of grass?
No, just leave them there. I don't know why you want to move them. You're just making work for yourself.
Well, I don't know, you might leave them there for a week, but you might want to move on, just let them to rest and go to seed.
It's going to go to seed anyway.
Okay.
The only way to stop the rest going to seed is put more animals.
Yeah.
Do you understand?
Yeah.
And if we put more animals on there, what are we going to be doing? More dung, urine, and dollars. Hey, magic.
You need more.
Isn't it a magic thing, this ecology? You do need more paddocks to make this thing work really well, and we'll get to that in a minute, but you do not need too many paddocks. If you guys have got more than 30 paddocks for a mob, you've stopped thinking. Joel Saladin, that conference that I was talking, last conference I spoke with him, I've spoken at quite a few. If you ain't moving your cows every single day, I don't even want to talk to you, says Joel Saladin. Lucky I'm talking after him, eh? If there's any one of you, says I in my best American accent, pricks Americans, yeah, if you're moving your animals every single day, says I don't want to talk to you because you ain't thinking. Joel Saladin doesn't run into a problem with it. Why? Because he has so much diversity in his actions and his activities. He does not run a 120-day recovery period. His cattle are here, they're there, then they're back here, then they're there, then they're there. Then it's a rabbit, then it's a guinea pig, then it's a freaking goose. You know what I mean? It's never going to be the same. Old mate is not going to get into a problem. But you are the classic quintessential Australians. They said 120 days. Fuck me dead. Brainless. Just repeat, repeat, repeat. I went to this bloke's place in a wool shed in central New South Wales. He just wanted to show everybody his grazing chart. I said, don't show them your grazing chart, please. I want to show them my grazing chart. Please don't show them your grazing chart. Eventually, shows his grazing chart. He's got 10 years of freaking grazing chart. So you know what I mean by that? It's got days across the top, paddocks down the side, and the movements of the mob in it. 10 years. Mate, the first one and the last one were identical copies of each other. The moves were exactly the same distance apart, all the way across. Every 3 months in the paddock. Every 3 months in the paddock. 200 cows. 3 months later, 200 cows and 200 calves. 3 months later, 200 cows. Do you know what I mean? Guess what I said? As soon as he showed it to everybody, there were 200 people in the shed. I said, oh my God, the sex life must be up the pole on this place. What do you mean? He said, because he was jolly proud of this. He had his zip open, you know, he was like, he had it out there to get the pat on the back from everyone. I said, mate, so how does the sex life work on this place? He said, hey, it's Wednesday night, 9 o'clock. Sheila, brace yourself. Is that how it works? Wednesday night, 9 o'clock, brace yourself. Is that how it works? Like just doom, doom, doom. Where's the romance in this thing? Where's the change? Because the second thing I want you to take home today is that if you're not making changes, everybody happy that means change, the triangle sign? If you're not making change, you're not going to get change. Change is equal to change. A little bit of change equals a little bit of change. Yeah? A mother of a big change is likely to equal a really big change. What does no change equal? Pardon?
0.
Good question, good answer, but no. What does no change in what you're doing equal? It actually equals less than you had before. Okay? Because, and I'll prove this to you in 2 minutes, the third, so this is number 1 principle, this is number 2, number 3 principle is that nature, can you see that all right, mate? Do you? I'll just do it all in black, eh? Do it all in black, mate. Nature works in patterns and wholes. Jan Smuts' statement. This is Dick's statement. That one is older than old, but the Lassiters is where I got that from. I got this from Jan Smuts. Savory and them have got this thing as their main originator as to why they've got holistic management. But what they've missed is it's not about the whole, it's about the pattern. The pattern is what creates the whole. And any time there's a pattern, holy moly. Everybody happy for me to turn pages?
The patterns and
Nature works in patterns and wholes. So they've used that to make the holistic everything and being affecting everything. But what they've missed is actually the patterns that create the wholes. And what we need to learn to do is to look at patterns, because this is the next principle, is that thermodynamics, laws of thermodynamics apply in ecology. First law is that there's a given amount of energy in any given whole. Second law of thermodynamics is that as soon as you've defined the energy in a whole, it will begin to, is it 1 O or 2? Lose? 2. Cool, that's how I spell it, 2. Is it only 1? That's one that's always battled me. Lows. I always spell it with 2 because it makes more sense to me. Loose is 2. Okay, cool. So that's much better. So lose energy. The moment you've defined it, you will begin to lose energy out of that hole. So you build the Sydney Harbour Bridge. You can go and look up in the City Hall there how much energy went into it, how many labour hours, rivets, girders, the whole, it's all written up exactly what went into building it. When they finished building it and broke a bottle of champagne on it, guess what the outcome for that thing's going to be? It's going to break down. With expansion, contraction, the rivets are going to get loose and it's going to end up as a reef in the harbour.
I'll just qualify that. You actually never lose energy. The energy just changes state.
It changes state, it's correct, but it becomes unavailable in that hole.
State of disorder.
Into a state of disorder.
What's the first law?
There's a given amount of energy in any hole. And the second one is that you lose energy out of that hole. There's a couple of different explanations of it. The one, I watched it on YouTube the other day and they used this loses energy, but they did qualify it that you can't lose energy, but it gets lost out of that system of that hole, right? It's still around, but you lose it out of that hole. Anyway, more or less along those lines, that energy gets tied up and it becomes unavailable. How do we stop this happening? How do we maintain that thermodynamic whole?
By constantly changing it.
That's right. So your third law is that, as I understand, this here is called entropy, is the second law, entropy. The third law that these chaps are using when they explained this to me is the law of syntropy, which is where organisms working together are able to stop entropy from taking place. So, the Sydney Harbour Bridge, they put old Paul Hogan on a door with some block and tackle and they lifted him up and down the side and he was tightening the rivets, chipping off the rust, repainting those little spots on the thing. That's maintenance, right? At some stage in the history of that bridge, they wanted to increase the number of lanes and rail lines on it. Was that something they could do as a small job, or did they have to throw a catastrophic event at that bridge? They had to throw a catastrophic event at that bridge. They actually had to stop the use of the bridge for a while they went and added lanes and railway lines, etc. to the bridge to make it go on. So that is a catastrophic event. Unless you change catastrophic events into a landscape, you will have entropy slowly but surely setting in. So at any time that you're driving a thermodynamic hole with a set pattern, you're going to end up with less than what you started with. Is everybody happy with that?
What was the second point on the next?
Thermodynamics one?
Yeah, the middle one?
Entropy.
Yeah, equals something lose energy.
Oh, this one here?
No, the one that's wrong. Yeah, that one, the middle point.
So the loss of energy is entropy.
Oh.
Yeah, it's the same one. Sorry, it's just, yeah. That's the correct term for it, I understand, is entropy. entropy. And the opposite of entropy is syntropy, or like synergistic opposite of entropy, where organisms start working together to actually create more energy. It's not creating energy. Energy can't be created or lost, but it's reorganizing energy so it's more available in that whole rather than being unavailable in the whole. Would I be more or less on the line with that, Dean?
The way I look at it is if you have like a marble in a bowl running around your finger at a certain level, and you're doing that by putting a bit of energy there to maintain it at that level. But if you let it go, which is like we're talking about here, it will naturally revert to the lower state of energy. And so to maintain coming back to your triangle there, if you have
change.
If you inject energy into that, if you like, to increase the energy.
So 2 quick vroops with the marble.
Just like the impact stuff, or events. Then that will change state to a higher order.
Is everyone happy with that? Okay, now let's bring this back to a Dick Richardson. Now you've got to remember this is a proper Dickism, eh? This is not currently what you would be taught at school. These organisms here, grasses, are higher order plants. Mycorrhizal fungi is a higher order saprotroph. Grazing animals are a higher order animal. What do we mean by higher order? They've evolved more recently. Yes? So which way does succession actually go? Succession is not increased succession to trees, it's actually this way. And why did we draw it the other way? Why did we all get taught that trees are the natural succession after grassland? I know why. It's because in Western Europe, it's where we all come from, where all these written, current, trained things come from, is the moment we took the grazing animals out of a landscape, what happened to it? It turned into a woodland. We assumed that was succession. Therefore, we wrote it that way around. If it had been Dick writing those textbooks, I would have written it the other way around. I would have said you add animals in it to improve succession, to increase succession.
And that's part of the sort of ideological challenge you see in the world, that animals being part of the system and get rid of them because it reduces the methane, and therefore the climate's going to be better or live happily ever after. We should just eat vegetables. I think it's misguided because it actually misses how the whole system functions.
That's right. And it's missing the evolutionary process that made this happen. It's missing how those soils became deeper and more mature over time. Because remember, I didn't draw the plants up here, but look at this matching my picture from just now. And then add one more thing on here. Oh, whoa. Woe is me. Any carbon standing in a plant's got to enter the carbon cycle. Byproduct? What was the byproduct? Methane and carbon dioxide. You have no choice. It's going to end up having to go into the carbon cycle, so it's up to you how you do it. Okay.
I think there are other things at play that surround this, because I think there is, there's also a whole natural world that does jobs. We've got little birds, we've got a whole lot of critters.
A whole lot of critters.
A whole lot of work.
Yep.
And our farms can become places that support those critters.
Yes.
Or not.
Absolutely.
Our flowering trees, we've got extraordinary eucalypts. The most flowering giant creatures you could imagine. And probably, I don't know, where else in the world they're like that. You know, this masses up. It brings all the birds, it brings all the critters, and they do work. So we have to be careful. We don't forget about the work they do and keep their environment and our environment farm.
Really, really cool. So remember that the emphasis I'm putting on here is that if it's a grazing community of a grazing function that you're looking for, allow that form to define itself. And those trees, those shrubs, those forbs that are orientated with it will be there. The grasses, the trees, the whole lot of them, all of them will pitch in there and do that for you. It's not, I'm not an anti-tree person. I'm not saying don't do this. It's about diversity. But remember, this is very important. We're identifying here, and it's a no-brainer. All the things you read about, all the things that you study, Christine Jones, a whole whack of them, biodiversity is king. We need lots of organisms of different species present.
And I just want to remind everyone, on a really hot day, just get under a eucalypt. It's an extraordinary creature. It cycles cool air.
To step under a deciduous tree, and it'll be another 20 degrees cooler. Yep. So let's go under a courage, it's another 20 degrees cooler. Anyway, I'm not having a go at the old eucalypts, I'm just reminding us that it's a part of the whole. But what I just want to finish off with that particular statement is to add to what you're saying. How many people do you hear about in this grazing industry that keep telling you they want a biodiverse outcome in their paddocks, who then run a repetitive grazing system, like even a cell grazing, think 30 days when it's growing fast, 60 when it's growing slowly, or 30 or 90, or 120-day recovery period all year round, whatever lifts these people's boat, right? They are creating with the same species, the same repetitive action, no change, does not increase biodiversity. It is change that will create biodiversity. You need to have the goat, you need to have the sheep, you need to have the cattle, and you need to be varying your recovery periods, you need to be varying the level of grazing, you need to be allowing sometimes seed set, sometimes not, to create biodiversity. Is that understood, that Dick's not just a one-liner? Okay, so what we're going to do next is how do I, with grazing naturally, create that change on a sustainable, developmental, regeneration of soils, long-term basis. And how do I keep that going with good animal performance? Okay, that's what I'm going to do next. Any questions before we go to the next step? We're going right time-wise, Dean? Because leave me enough time, please. I need to go outside there and get a little grass plant out to show people that it will be producing sugars, and its root systems will actually be quite healthy, even if it's only one of these little buggers. And right out here, there's 2 spots where I'll be able to find a proper woodland ecosystem to show you, where you can smell the difference between the two. And this is somewhere where we don't even have my favorite thing happening. Sorry, I chucked it all the way down. Like that smell, Tom? The other day, I was passing around a really fresh cow shit.
I think you've just invented a new form of strange worship.
You like that smell? You like that smell?
Smells kind of like grass?
Yeah, it's fermented grass.
Oh.
So it's come out of the arse end of an animal. Yeah. Anyway, the other day I was doing this with a really fresh one, and this bloke hit my hand up under this girl's nose, and she had a bull ring in her nose, like one of those nose ring things, and there was cow shit hanging out of this thing for the rest of the day. Poor chick. You smell that? Do you like that smell? It's one of my favourite smells. I just love the smell of shit. Animal dung, that is.
Yeah. Just
you know, at school.
The opportunity we've got to access Dick's wisdom between now and when we finish. There's still only a couple of points on that board here, but I guarantee everyone's got at least one question they want to get answered.
Should we put it up there?
Yeah, that's the idea. There's a couple of pens over there, write the question up there.
So did you get that lovely sweet smell? Lovely sweet smell, eh? That's a rupu that I picked up this morning. Okay, that lovely sweet smells come through there. It's fermentation. Greatest thing you can get. When we were at junior school, boarding school, we used to get so freaking hungry because the food was so short that we used to make hamburgers out of horse shit with manna from the gum trees in the middle. It was actually quite nice. So maybe that's why I get so excited when I smell those hindgut fermenter. I think it's lunch. Righto. Any more current questions on what we're up to, other than the ones going up on the board?
I think one of the questions which Carla or Anne-Marie talked about we get this spring, I know we haven't had very good springs in the last 3 years, but that's our growth season. And then you don't have enough animals to put out there. I'm sure you get some senescence and seeding and so on.
Yeah.
And you can turn some of it into hay and stockpile that, and that's fine. That's a form of insurance. But at the same time, in the back of my mind anyway, from all the learned people out there like yourself and so on, saying, well, get rid of your machinery.
No, I'm definitely not that person. That's an RCS thing.
Yeah, so that's...
Use your machine to keep some of those plants in the stand. If you can't get to them, cut the frickin' thing. Turn it into hay. Even better, turn it into silage.
So that's exactly what I want to talk about, because we've got that window, which is basically the dollars in our pocket that doesn't end up in our pocket.
Yeah.
And we don't manage it properly, so it's a huge opportunity to get it right.
Yep.
And spending a lot of money on a contractor to come in and cut hay, they'll charge you whether it's good hay, bad hay, whether it's cut in the wrong time of the day, or whatever. We know that story, so I don't think that's very effective. But we don't necessarily have the equipment to go and buy it ourselves. It's not efficient. So, silage is probably a terrific way to do it. So it's just a big conundrum how we most effectively deal with growing.
Go to the contractor. Ask the contractor when the rest of the districts are not idiotic enough to cut the hay. There'll be a time when that contractor is driving around using diesel trying to find some way to cut the hay.
With the seed head on it.
No, everybody's waiting for that to happen.
Yeah.
Get him to cut it early.
Yeah, that's what.
And he's got the spare time then, because nobody wants him then, because it's not profitable to cut a hay that's only this tall.
So you're getting in earlier.
That's right.
We ended up last year getting hay that was cut from a contractor, a hay supplier we used, and we'd saved some in his sheds. So it was not last year, the year before, when we hardly had any rain, and he cut hay this short.
Yeah.
Oh my God, it's such fantastic.
Such fantastic hay.
Oh my God, they're just...
Hello, baby. Yeah.
When you've got really poor feed, that hay, dynamite. So we've fed it over the summer.
Yeah.
Best milk over summer ever.
Best. I sent a newsletter out just before Christmas. Garth did for me, which had some pictures on it from the Eyre Peninsula, where I went to go and see this bloke. It was the first time I'd been to his place, but he asked me to come out there. A fella called Terry Young. And their growing season this last spring on the EP was really 2 weeks. From when it was too cold and wet and miserable to bang, gone and done. Had about 2 weeks. And I'd got there, it was just right at the tail end of this, and I'd been I run the grazing management on a place lower down on the EP. So I'd been over to that place, done the grazing planning again or whatever, and then gone up there. And I'd been the whole time there just, come guys, get the mowers going, cut the stuff, because we're going to run out of growing season. Just cut anything we haven't been able to, because we're not going to be able to. Our animals have got to go for the next 10 months still on the feed that's left. We cannot go and suddenly produce like 1,000 times a number of animals that we need right now for this feed thing. We're going to miss it. I got to Terry, told him the same thing, and he said, it's funny, that you should say that, because I did a tour with the KLR guys, Graham Reese, and they'd been to the US and they'd gone and visited a few regenerative people over there, including the really famous guy. No, I can't remember the guy, this one that I wanted to talk about. Anyway, but they went and saw Gabe Brown, for example, and they saw others. But they then went to this other bloke's place and they said, Dick, what you're telling me is 100% what this bloke was telling us. When that hay is this big, tall, cut it and get it to keep pushing the sugars into the ground, because that's how we're getting the changes. So he took me to 2 paddocks. And this is what the pictures I sent out. Christine Jones uses them now in her speeches, these photographs. There's a mixed poly pasture of stuff that he's planted, both sides of the fence the same. Okay, the same stuff. The one is this tall, uncut in seed and in flower. Okay, the other one, there's 2.2 tons of hay standing wrapped in round bales in the paddock. Hasn't had time to take it off because he was cutting other ones. It's regrown this much material, which is 1,300 kilos, so I gave it 1,200. That's 1,200, and 2,200 is 3,500 kilos of dry matter come off that paddock. The one next door that is this tall is knee, that's 12, that's 15, that is about 1,400 kilos total dry matter produced. total in the other paddock. So think about it this in terms of economics first. Now, the key one, I've taken my little spade, which goes everywhere with me, and I've done squares out of both of these paddocks. The one where he cut at 35 centimetres in what they call a toxic white sand. In other words, it's so high in aluminium that it's known as a toxic sand. We've got roots of an oats plant producing root exudates. The roots are like dreadlocks hanging on the plant at that level. There was not a root deeper than 20 centimetres in the uncut one. So economics and ecology, outstanding return for that property. Now, I'm not saying you have to go out there and cut everything, but it's an option to help you get to more of your country to keep it right. And I'll explain where that fits in a minute in the grazing thing.
So I think in some situations then, even if you went in with a slasher just to cut it so it regenerates in that vegetable stage, even if you didn't bale it or use it.
Is that a good idea?
I mean, I wouldn't have thought it is.
Yeah. There's two things that it does to bugger up your show. One is it puts a whole lot of mulch down its soil surface, which then drives this community. And number two is the one that we haven't even got into today, is the amount of nitrogen it'll tie up at soil surface. Yeah. These are nitrogen poor situations. The only way they can get the nitrogen is with the rhizobium. So you've got to be really careful of doing that. However, look, if you didn't have a choice, do that. And there's a guy that I work with on Kangaroo Island. Sadly, they've been burned out this particular year. But anyway, a very nice young fella. He is doing swath grazing. So they don't even bother to bale it. Swath grazing, which is the thing I came across in Canada, where they cut the hay, but then don't bale it. They just rake the windrows into deeper windrows. So they just rake 8 windrows into one and just leave it in the windrow and then grow the grass in between. They might do that a second time and rake it up next to the other one and then just graze it off with the temporary electric fence, but they let out one windrow at a time type of thing as a supplement for stock. So, you know, if you're really desperate, that is actually not a bad way of doing it. So you'll get a bit more whitening off of the hay on top, but if you make your windrow big enough and you make the windrow just when that hay is close to being made, you can actually get it to be pretty good quality hay underneath that. Yeah. And I said to these chaps, I said to them, don't forget the old buck rake. And most people in Aussie don't remember what a buck rake is, but when I grew up we were still making all the hay we made in haystacks by hand. So later on we got a baler for it, but that would have been the equivalent of nearly 4,000 big round bales, those 600 kilo round bales that we used to make in those days of hay every year, and that would be up to 4 cuttings we'd make, and that was all done by hand, as I say, when I was a younger bloke, probably until I was like 14, 18, something like that. But I remember getting home one day from polo and having to stop a fight between 2 blokes. One had a pitchfork and the other chap had the tractor with the buck rake on, and he was chasing him around. The buck rake is a reverse rake, which once you've made the windrow, you take the buck rake and you just go backwards with these sparks, you know, like a carry-all, but with sparks. And that's what most buck rakes in Australia ended up becoming. People tied wood on them and turned them into carry-alls. So you push it back until the stack gets too big, and then you just turn out of the windrow, push it up to the haystack, and that's what was forked up to build the haystack. So it's called a buck rake. So if you made your big windrow and then you just buck raked it until it was getting too big for the tractor, and then got out of the row and did another one like that, you could actually make little miniature haystacks. Yes, there's going to be a bit of wastage of quality in there because the rain, it's not going to make a perfect stook, obviously, you know, with a proper head on it to shed the water, but you'll still make a cheaper, really good quality, relatively good quality hay in most of them if you did that. And if you're a smaller operation, well, you could then take a pitchfork and just make a bit of a crest on each of those stooks, you know. Yeah, a little haystack. Righto. So certainly, I'm not the person who says, go home, sell all your gear. Keep your gear. I want you to be able to plant poly pastures with that old bugger thing. I want you to be able to aerate a paddock here or there. I want you to be able to make hay make some silage. We used to make silage in the middle of each paddock when I was a kid. It was just taken there, dropped, the bullocks used to trample the stuff in, and then we just plough a circle around it and bury it under sand and dig the sand off the top of it and then graze them out of there later on. It was really simple farming in those days. We knew a lot more than we know today, I think. Rightio.
You had sandy soil, you say?
Where I grew up?
Yeah.
No, we had lovely, beautiful
and then you
loams.
poured in sand and put it over.
Oh, we dug the soil out round it and just tipped it on top. Yeah, to make it anaerobic. But like my last job when we sold those properties I grew up on, so this would have been in 1990. Yeah, 1990. My last job was to take the last 2 bullock teams and load them on the train and send them to the abattoir. So we still used to use bullocks then. So the bullocks would be led over and backwards and forwards over the silage stack to trample it to push out the air. Yeah, still, that amongst other jobs, obviously. Yeah. Righto, can I get into some really hairy detail about how you're actually going to run this grazing now? Okay, cool. You'll have everybody's addresses, won't you, Dean?
Email addresses?
Email addresses.
Got all those, yeah.
Cool. And when Dean sends out this stuff, you will have my email address. You can contact me with questions. Please send me photographs of your paddocks. Show me what you're doing. Skype with me as much as possible for the results you're getting, okay? Because I love it. Right, so we're now talking about the grazing naturally method. I'm obviously not going to go through the detail of how we do the mathematics and all the rest of it. That we'll have to leave for another day, but it's a good starting place. Everyone all right? That's where I'm going? What we do is for a mob, so each mob, however many mobs you run, we give them a set of paddocks which we divide into seven zones. Okay? One of these zones this year is going to be called the priority zone. One's going to be zone 2, there's going to be a zone 3, a zone 4, a zone 5, a zone 6, and there's going to be a Sabbath zone. Okay, so these are zones, 7 zones. This could be 7 paddocks, it could be 7 zones of 3 paddocks, it could be 5 littler paddocks in this zone, 1 big paddock in that zone. You know what I mean? It's just 7 more or less reasonably equitable zones for this mob stock. Okay. Optimal would be to have round about 3 in each one, about 21 paddocks for a mob stock. Okay, you could have 28, but if you're getting more than 30, wait, that's ticklish. If you're getting more than 28, you're going to stop thinking, so just don't have too many, okay? If you've got too many, have 2 mobs rather. Right, what you're then going to do is you're going to sit down and admire your handiwork and drink 2 beers, okay? One you're going to squash down like this, and the other one you're going to fill it up with sand or something that heavy that's not going to blow away, okay? You take these 2 beer cans and you put them in your priority paddock, okay? 1, 2, 3, 4, 5, 6, 7. So I'm going to divide this farm of paddocks that I've got here into these 7 are going to be given to one of my mobs. Is everyone happy? I might have another mob running here and another mob running there. Those are my trade cattle. These are my 1 mob of cows, for example, and this is my heifers. Maybe my heifers are running with my steers if I'm getting a bit naughty. I'll run them together. Okay, everyone happy? So do you follow what I've done here? I'm going to pick out my priority paddock, which is going to be this young man this time. So you're going to take these 2 beer cans for me, okay? And you're going to have to manage them. So you're going to have to be the priority paddock. I'm going to make this zone 2. This one's going to be zone 3. Zone 4, Zone 5, Zone 6, and this Sophia paddock is going to be my Sabbath paddock. Is everyone happy? Okay, now I've got my mob of stock, which I'm going to move around, and I'm going to be the mob of stock and the manager today. So I'm sticking, it started to grow. Everyone happy? It's beginning of growing season. This is a wet season scenario. I normally draw it green, but I had to think of poor old Dean. So this is growing season or wet season, depending where you come from in the country. So I've put my stock into this paddock here. Your name, sorry, mate? Ant. So I've put them in the ant paddock, right? Full of bull ants and terrible bloody paddock. So I've put them in the ant paddock. How much am I going to graze out of the ant paddock? I'm going to graze it until, lift it up higher there, Ant, if you don't mind. I'm going to graze it until I can see that beer can. Okay, is everyone happy? Right, now you're going to grab this one, Ant, next to that one. Remember, it's all this tall. What you're going to do over the next while is you're going to grow it back until I can't see this beer can. Is that okay? Mm-hmm. Right, now you were zone 2, weren't you? So I've been through the 3 paddocks in zone 1. There's only 1 paddock here. I'm going to graze this one here now. My rule here, though, it doesn't have to become squashed beer can high. This would be either squashed beer can or for a graze period that I've calculated for this paddock. Okay?
On what basis have you calculated?
On the amount of time total that I need to make a decision and enact that decision to purchase more stock or sell more stock if it's not working out this growing season. Okay?
So
for the 6 paddocks.
Cans.
I'm keeping an eye on those cans. My rule of where I go to in this paddock, I either go back to zone 1, my priority paddock, if the beer can is fully grown, or if it's not, I'm going to go, the stock going to go to zone 3. Okay, is everyone happy? So I've grazed this one, I'm going to zone 3. Look, it's starting to grow pretty well. I'm in zone 3 and I'm grazing it, and I reckon that if I went to zone 4, if I went to zone 4, I'm going to be too late getting back to that paddock. Is everyone happy? So instead of grazing 4, 5 and 6, I immediately turn out and come put the stock back into this paddock to graze it down.
Sorry.
Yep.
That's because of the priority paddock.
Yes.
And what defines the priority paddock?
It just, in this case, happens to be this paddock. But you'll keep your hands down for a minute there, and you just get exhausted. I used to spend a lot of time trying to teach people how to identify which paddock should be a priority paddock. Okay? But for you guys, just really the paddock that the stock are in when it's green, start with that one. Okay, it's a priority paddock. But really, it should be the paddock that you think is one of your worst paddocks. Okay? However, this lovely lady here, and I happened to pick it by accident, do you notice she's got quite a lot of grey material hiding in the thatch of that beautiful hair? Do you see that? That's my lazy paddock. Everybody happy? It's gone a bit grey. That's why I've put her at number 4. Because she's going to get 4 years of more intense grazing before she becomes a Sabbath paddock. So she's going to get the best treatment I can give a paddock over the next 4 years. And I'll show you why. Okay. So I've grazed this paddock, it had second graze now, Ant, and I've grazed it down to this crushed beer can. I'll move my stock into paddock 2. How many grazes have you had now? Zone 2, second graze. I'm into zone 3, second graze. And it's growing along a little bit. Zone 4 is getting a graze now. And we're nearly there. I'm not going to go to zone 5. Everyone happy? Because I need to move back to the priority paddock. So I drop this and I go back to the priority paddock. And I put the stock back into my priority zone. Okay, so stick that down again for a minute, and write your notes. What I'm doing here is I'm picking out a place on this set of paddocks where I know I'm going to be able to keep these plants in this paddock in this really highly operating vegetative zone. And I'm going to make sure I get that right. My goal is to finish this growing season with storing that amount of feed, with a stored beer can of feed. Okay?
In the priority paddock?
In my priority paddock, yeah. So if it's getting to the beer can height and it doesn't have enough moisture in it, in my opinion, to replace the beer can, I don't go back to it. I now go into non-growing season thinking. Okay. The best I've managed to do with this is 14 grazers in my priority paddock in one growing season. The best any other Aussie, because I'm now an Aussie too, has managed to achieve is 9 in one growing season. The more the merrier. I'm giving these shirts out as prizes to people that can get it up into double figures.
Can I ask what your rainfall is?
That was at Burrawa, which is a 600 mil. 600 mil rainfall area, equally spread throughout the year. And the year I managed to get that right, I managed to graze it from those 14 grazes between the 1st of June and Christmas Day. So I was pretty happy with that. So it grew pretty well that year. Next best I achieved there was 6.
Dick, what do you do with the paddocks you never went into?
Yeah.
Cool. We're going to get to that, Tom. But that's right. If I could, I would certainly. My number 7 is like Sabbath. This is Sabbath. This is like the holy grail of this thing. If I'm going to do what I'm doing to poor ant, no.
You're saying that's best when you say the Sabbath?
No, definitely not. That's going to be the best tucker. That one.
Location and best feed. Because you want something central to be moving back there.
Yeah, well, that's why I put you guys in this order, so that it's not too far to go back to my priority paddock.
So it always has to be your best paddock out of the group of paddocks.
No.
You said it was the worst paddock.
Yeah, one of my worst paddocks. My very laziest paddock, I put at zone 4 this year. This one I sabbathed is probably the paddock that you think is your best paddock, and you've been butchering it for years because you think it's your best paddock, the one I'm sabbathing. This is the paddock where I'll get an automatic response of germination of red gums, because it's my Sabbath year. It's going to get 12 months off this paddock. I'm going to correct in this anything that I've potentially been doing wrong by forcing this too much of a grassland. I'm going to have a pH change in this paddock from, let's say I started with a pH of 5.2. By the time I've ended up with this paddock as a priority graze and I've grazed it 8 or 9 times, my pH will be 4.6. That's how much I can push up the nitrogen in that soil with that process, which will acidify that soil. Already jumping ahead here, the next year, this paddock here is going to be my Sabbath paddock. And in that year, I'll jump the pH from the 4.6 that I pushed it to, from 5.2, it'll jump to 6.8.
6.8?
6.8.
6.8.
Yeah.
Have you seen changes like that?
Yeah, I've created that. I'm quoting numbers where I've done that myself and done the pH test.
The pH is dropping because of the huge nitrogen.
Because of the nitrogen shove, because I've pushed these biological communities so strongly in there that it's just pumped nitrogen, 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 nitrogen. There are obviously other things going on, but that's just a simple version of it. So I'm shoving this thing. How do you teach a horse to do things? You put pressure and you take pressure off. Is everyone happy? Move, stock, pressure, release. I'm pressurizing here. Pressure, 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 pressure. I'm going to take the pressure off and let it be the Sabbath the next year. So I'm jumping you guys ahead to that right now already. But the goal that I'm trying to get here is I'm going to end the season with a beer can of feed in the ant zone, because that is going to give me a really quality dried off feed to put young stock on. I can wean hoggets onto that and they'll grow. I can finish near, in northern Queensland, I can finish near boat weight cattle that otherwise are going to have to wait. This is, I'm talking about in, get it right, Dick. This is in May, April, May. I can take those cattle which are going to have to wait till next February, March to get to boat weight, that next 15 kilos, and I can finish them in zone 1 and zone 2 and get them out on a boat for like $1.20 more than I would have if I'd done that and sold them ready to go at the end of the wet season. Okay, so there's all sorts of tricks I can do with that particular one. But I've got really high quality tucker. This one actually, funnily enough, is pretty near to closely the same. And usually, interesting of all, zone 3 is only going to be about this tall. Because this is the one that I'm going to be in when that growing season's pulling up and I'm deciding not to go back there. So this is going to get probably the least regrowth. So these are all really good quality feed. So maybe I've got 5 grazers, maybe I've got 4 grazers here. I only got 2 over here, and I didn't visit zone 6, and I didn't visit, zone 5, and I didn't visit zone 6, and I didn't visit zone 7. I absolutely didn't on purpose with that one. With these 2, I've got the choice of deciding, well, hang on, why don't I just run a mower through this? This is before I finished all my grazing, obviously, but this is still during the wet season or the growing season. I could have mowed this one maybe and put it away, and mowed that one to put it away. Or put a trickle of crop into this for the summertime, or, you know, I've got options to do with these things that I can do other jobs with. Okay, if I'm only getting out to zone 3 and dropping back to the priority, zone 3 dropping them back to the priority, what is that telling me?
Not enough stock.
Thank you, sir. Not enough stock. What do I do about that?
Buy more.
I'll buy more stock, correct.
Right now.
So I'll dash out there and I'll get a couple of hundred more, a couple of thousand more, and what do? I bring those animals and I take them into the zone 5 that's getting left over here, or zone 4, the zone 4 and 5 that are left over here, zone 4 and 5 that are left over here. Follow the logic? So I can use the extra paddocks with these other mobs of stock that I can sell. Okay? Alternatively, I'm getting...
So you don't join the mobs?
Oh, I don't need to, because those are trade cattle. I'm worried about biological warfare and all the rest of this. What's that thing called? Biosecurity. That's the one. Yeah. So instead of joining those 2 mobs together, and these are heifers and those things are steers and they've come from everywhere, and there's a couple of them are going to have the odd battery left in them. What a problem. I'd rather just run them separately, for example. Okay? Or in my case, in Burua, this was a cattle operation. My trade thing was a big mob of wethers. I'd have 2,500 wethers, and I'd bring them in and I'd use those extra paddocks with those wethers. Okay? The one I ran later on down on the Murrumbidgee, near Gundagai down there, it was a sheep operation. So I'd bring cattle in to do that job. Okay? Conversely, my priority paddock, so I've grazed you down to the beer can. Now, and grow real slow for me this time. Into zone 2, but I'm going to probably be leaving a bit of feed behind here. Into zone 3, and it's trickling along. I'm into zone 4. I'm getting to zone 5. What am I going to be doing here?
Be selling, I think.
I'm going to be selling. Thank you. I'm going to be selling. So what am I going to sell? I'm not going to sell my replacement heifers. I'm not going to sell this mob of my famous favourite cows. This is where my trade cattle were, isn't it? So I'm going to sell out of here. And what am I going to do then to survive this thing? I'm going to go on. It's not going to quite get there because it's not going to replace that can. So I'm not going to that. I'm going to use zone 5 and zone 6. And I'm going to pull those cattle out of here and there, and I'm going to share with them the paddocks that I haven't used out of my sold mobs paddocks. Do you see what I mean?
You run them together, you say?
Well, I could bomb those cattle together if I was getting desperate, or those sheep together, but in this case, let's just keep it simple. All I'm doing is I'm borrowing the paddocks from this mob, which I've now sold. It's all gone. I've sold my steers, I've sold my wethers, I've sold my trade cattle, you know what I mean? I'm coming down in numbers to try and save my Sabbath paddock.
Is this where you use the grazing chart to work out what your carrying capacity still, or your grass inventory that's left here, or not?
That'll come up shortly, calculating the close season.
Otherwise, how do you know that you've got capacity?
Okay. So the bit of this that I'm covering at the moment is during my growing season. I'm grazing away from priority paddock. The closer I get to my Sabbath paddock, the more of a warning I'm getting of being overstocked. I don't need the trend line to do that. You know what I mean by the trend line? Is that what you're referring to when you're talking about a grazing chart? Stock days per hectare per 100 mil?
Yeah.
I don't need that thing because it's highly inaccurate anyway. Okay, because one year is efficient rainfall, another year is inefficient rainfall. So I don't even bother to use it. It's in the Maya program, but I never use it. What I'm interested in is how far down my priority paddocks, away from my priority, how close I'm getting to my Sabbath is telling me at this point. However, you then put the other concept together with that, which was the concept of doing a grazing budget. Dean, that's my next job. As soon as I'm deciding I'm not going back here because it's not going to replace that can of feed, and I'm getting on through these paddocks towards my Sabbath, I will do a non-growing plan, which is go around and measure every single paddock's available feed. First. That's what you're referring to. Okay, so that is what I call a non-grow plan. Okay?
Which is essentially most of the year, like
a lot of the year. And so, how much tucker is there going to be left in ant paddock?
A beer can's worth.
A beer can's worth of feed. Right? So if you go to my website, you'll be able to download the stack method of calculating how much feed there is. It's pretty self-explanatory. Beer can of feed standing in the paddock. It's just above my ankle. That's 90 stock days. So it is 1,000 kilograms of dry matter per hectare. That's what I've got in this paddock. Of grazable feed, leaving litter on the soil surface. I don't have to go cut anything. I don't have to weigh anything. I don't have to stuff around with all that. Some of you might have been taught to do the squares. How big my square must be to feed an animal for the day. Anyone here? Anyway, lucky you haven't. You have. So when you do it looking into the sun, you get a different answer to when you're looking away from the sun. Yeah, because the same paddock looks totally different. I'll walk over there, there's lots of tucker over there, and you get there and you look back, there's no feed there. You know what I mean? This is what it goes. So we use the stack method. It's pretty simple calculation, so using your beat.
Equals 1,000 kilos.
Yeah, so what it is STAC, Sol. Are you watching my time, Dino? I wasn't planning to really cover the stack thing today, but we'll do it over the internet. How's that? Right, that's a boot. Very, very sexy one I drew there. S is sole, T is toe, A is ankle, C is calf. It goes on far, and of course with these buggers I work with up north, it's got pocket. This pocket up here. But most humans get quite different heights when you start getting to thigh and pocket. But almost all of us are very similar sole, toe, ankle and calf. Now you don't all need to have South Australian soles like mine. We need really skinny soles because we don't have much tucker down there. But more or less, if I can borrow your foot, this is a classic sole height. So that's the bit that you can't see through, and it's an average for the paddock. If it was just a wall-to-wall paddock, you could just go anywhere and put your boot down, would be the same height. You could just measure that way. These numbers are 30 stock days, 60, 90, and 120. These are stock days per hectare. I always work in kilograms of dry matter because it's more accurate than this whole stock day DSC bizzo. Kilograms dry matter per hectare. This here, it's times 11.25 basically, is the conversion rate. So this one here is more or less 350. This toe is 700. Ankle is 1050. And calf is 1400. Note the important thing to note with this thing, because it seems weird. It's like the Fibonacci thing. 1 plus 1 equals 2. Okay? 2 plus 1 equals 3. 3 plus 2 equals 5, because things grow less at the higher end of the plant than they do at the lower plant level, okay? But that's been well established. I got this from the eastern US states, northeastern US. I just had to translate it for places where one step will have a 0, one step will have 120, the next step will only have 40. So you can have any numbers in between. I take 10 steps, always with my right boot, always the same distance, and I rate that by how much I can see through. I'm going to divide my total by 10 to get an average. Is everyone happy with that? So before I do it, I already divide by 10. So instead of adding 30, I'd add 3, because they're easier numbers to work with. Soil is hidden on this one, 3. First step. Second step, bare patch, 0. My total is still 3. Next step, oh my gosh, that's up to my thigh that I can see through, that's 150. Add 15, so 15 and 3 is 18. And I count my steps, so I get to 5, I start again, I go 10, because I need to have 10 to make it work. That's how we use the stack thing, and we do it in every paddock across the entire place.
And then after 10 you divide by 10, did you say?
No, if you've already pre-divided by 10, the end number is your stock days. So this one's just below my toe, so I'll call it, it would have been 50 stock days, so I'll call it a 5, because I've already divided that by 10. So yesterday I would have driven, sitting in the passenger seat, we would have done, I don't know, 300 k's on a 10,000 hectare property, doing stacks everywhere over that yesterday. And those numbers will be worked through in this week, and they'll be finished up by the end of the week. We'll know exactly how many animals we can carry on that place to get us through to June. Right now, the one mob we we're running at about 200% of stocking rate of carrying capacity, total for all their paddocks. But we know we've still got trade cattle that can go. We can borrow paddocks from them, and we can get the thing to maybe match up. The job with this thing here is that this is for the non-grow. You can use it in the growing season. If you're using Maya, we teach you to try and do this every time you move stock. What's my residual in this paddock? What's my entry kilograms dry matter in the next paddock? Animals. Use, in other words, mass, body mass, times 3%. You'll be pretty close to what your requirement is. Okay? That's how it translates. But please just go onto the website there and download that stack thing. I've put it on there. I think it's the only notes I've got on there at the moment. Because the rest of my notes are, obviously you've heard me today, I can be hugely controversial to most people's mindsets. So I can't just put notes out there, because every skunk in the region is going to want to start pissing on my website, and I can't win a pissing match for the skunk. Okay, total amount of feed divided by the amount of time I need it for, including your hay, decide what you're going to sell when, etc., to get you to your date when you think your growing season is going to be cranking along again. So the maths we do with that is the same as you would do with a cell grazing feed budget or an HM feed budget with a planned grazing, exactly the same. The pattern of use is a bit different though. But we don't need too much detail on that now. But next growing season, I'm going to be moving my beer cans out of ant paddock and giving them to Kerry paddock. Okay, so I'm going to hand these over. You don't have to pick them up so you don't catch his corona. Pass that over to Kerry. And so Kerry's now going to be the carrier of the beer can. This is very important. This method, grazing naturally method, has been developed by me out of holistic grazing planning. Okay? So I've done holistic grazing planning. I've done it more detailed and for longer than nearly any other human alive. Okay? The second one is the cell grazing mobs grazing thing, where they're trying to graze only 40% of the paddock and doing the 60 or 30 day and then 90 days. I didn't do that myself. I was doing the planned grazing. I could just see the weaknesses of it with a couple of my mates' places, all right? And on other people's places. Then we had these two wonderful scientists in South Africa called Venter and Drewers. I better write their names up, because you guys will want to look them up. I know what serious you are. So Fenter is spelt like that. And I think he was the doctor one. One of them's a doctor, the other one isn't. Fenter. And the other fella's name is Drevers. Right? They created a grazing system called Venter-Drevers grazing system in southern Africa, and it's been used exceptionally well. In terms of productivity, right next door to one of the holistic places that I was having lots of heavy input into, these guys were doubling the animal performance that we were doubling. They were running twice the number of animals, and their ecology was in better shape than where I was trying to get these people to do holistic planned grazing. They were absolute maestros. What they did was a 5-zone paddock thing, and their priority paddock, that, like my concept, is sole high to move the cattle out of, toe high to put the cattle back into. Okay? The biggest difference between what they were doing and what I'm doing is their Sabbath paddock. So Sabbath paddock Sophia here. We would carve in. I do the same, carve or lamb in it at the break of the next season. I use that to hold up those things so that I don't run around taking lambs and killing them away from their mothers. I can set stock them in this country, maybe number 6 as well. They've got a good feed. Anybody heard of a fellow Aussie called A.B. Facey? Yeah, you've read A.B. Facey's book? And he came back from the war and he ran all those sheep up in Queensland. There were 2 big strong messages from Mr. Facey. When you lamb down a ewe, make sure she can get a full belly within 2 paces of where she lambs, and she will not walk away from that lamb. 2 paces, full belly. Long fibre length, increased body temperature, keep the lamb warm, no running away because I'm freezing my ass off, leave the little lamb there to die. Okay? Good quality mix of feed. It's at the break of next season. Okay. So they would have done the same thing, Venter-Drevers. That's who I learned that trick from. But what did Venter-Drevers do next now? So remember, this is the break of the next growing season. As soon as they finish their calving or lambing, red steer, burn this paddock. And the burnt paddock would now get the beer cans as the priority graze paddock. Well, not their beer cans, remember their sole toe thing. That's how they ran it. So what that meant was their paddocks, from being a priority paddock, got utilised less and less and less and less over those next few years, built up a lot of old plant material, and became a nightmare for them to manage, which is why they had to burn it.
So what should they have done?
Is what we do with the grazing naturally thing. My priority paddock becomes my Sabbath. My zone 2 becomes the priority paddock. So I'm going the other way. I'm using my paddock more intensely. Zone 5, remember in this example, only had 1 graze. Zone 4 had 4. Zone 3 had 5, 5, 5. I've used them more intensely. Do you see what I mean? My priority paddock, when it's going to be the Sabbath next year, has got no old feed in it. When I lamb in it next season, the end of the next non-grow, there's going to be old feed in here, but nothing's going to be more than a year old. I have not created a big old feed problem. That's the difference between Venter-Drevers and grazing naturally. However, the outcomes are going to be slightly different. The grazing naturally would create the right circumstances in a form follows function rule for a great big diversity of forbs and grasses and the odd tree and shrub that get on with each other in this ecosystem, okay? Key thing. The grazing naturally process is going to create a grazing-based ecosystem which is going to be full of grasses. It's going to, because it gets grazed so short and so frequently, it's going to have heaps of forbs in it, like the wonderful stories about the prairie and the Great Prairies. It wasn't just grass, it had flowers through it. but it was flowers that got on with grazing because it was grazed real hard so that those little forbs could come up. Okay? So these people and these people and these people that get on with that grazing ecosystem are going to be encouraged in that landscape. Vented rivers, however, didn't do that. Vented rivers is set up because of the fire, drove it not only to a grazing-based ecosystem, but to a fire-reliant grazing-based ecosystem. Critical difference. The species that they ended up with were all what in Southern Africa is known as the red grass group, which many of them exist still in Australia because of their fire reliance. They didn't disappear with the megafauna. Kangaroo grass, Thermida triandra. All your hyperenias, all your spear grasses, in other words, all your heteropogons. Those people are the red grass group as we know them in South Africa. Kangaroo grass is known as red grass in South Africa. Okay, rooigras. That's the stuff you'll end up with if you use a heap of fire. And you can add to it in Australia your Danthonias and your Microlinas. All of those are fire-reliant grazing grasses. You burn it, you get more of it.